Okay. So we have, we'll wait one. Okay. So welcome everyone. It's great to see familiar faces and names, and I'd like to welcome all of our new faces and names. We have people spanning the globe today at today's series. Today is the fifth series in Fred Brown's talks of defeating COVID-19. We mentioned this before, but again, if you want any additional information, feel free to reach out to me or Christine Forbes, and we will also be updating the website. So I'd like to take a few minutes to remind everyone of how we're running this meeting. We actually have it set up as a meeting instead of a webinar because we want to have the interactivity. So when you come on, please mute yourself, but also turn on your video. And as we get into the Q&A, then you can unmute yourself. If you have questions during the presentation, because this is a meeting, you have to submit them in the chat box, and we will be tracking all of these and making sure that Fred is able to answer those. And after the meeting, we will be taking questions from the chat box. You can also ask a question or raise your hand. So
Jean, I'm hearing from someone that's a little bit hard to hear you. Is anyone else having a hard time hearing Jean, or is she clear?
yeah, let's make sure that everybody.
He's gone over.
Quite annoying. This is all about the Harvard Business School thing about.
What? Oh, sorry.
How's that?
Okay, make sure you're muted, please. Great.
I'm listening to a classmate, HBS classmate, on this human variants and a vaccine.
Okay, please make sure you're muted. Whoever said you're listening to a fascinating Fred Brown talk. So, okay. So I want to begin by introducing our illustrious speaker today, Fred Brown. Fred has had a 40-year career developing pharmaceutical solutions, focusing on a lot of different epidemics. Fred is what we call a triple threat because he has experience in intervention for epidemics, pharmaceutical development, and also health policy and technology management development. And you'll see how all of those things come to bear today as he's giving his presentation. In addition, there is a support group behind Fred, and I'd like to especially thank people who've pulled together the messaging and slides, Christine Forbes, Tom Caudry, Arthur Zwern, and Cynthia King Vance. The new website, which I encourage you to go to, has been spearheaded by Arthur. Thank you, Arthur. Assisted by Tanya, Tom, and we've had a ton of other people suggesting inputs. Colin and Beth and Robert Poulin have all been giving us advice and information for the website and for our talks. Any of the modeling that you see today is actually coming from a Deloitte application that they've been generously provided, D-Smart. And then I am your host and moderator. So welcome everyone.
Sorry to interrupt you, Jean, but the new website's still at fredbrown.com.
Okay.
It will be migrating to askfredbrown.org soon.
Okay, so all of you should have the fredbrown.com website, but soon it will go to Fred Brown. If you just Google Fred Brown, you'll get to the website. Okay, so now comes one of the favorite parts of the talk, according to many people, which is the polls. So I am going to launch the first poll, which is your views on vaccines. So please look at this and click off whether or not you've received 1 dose, 2 doses, or you don't plan to get a vaccine. Okay, we have about 87% responding. Okay, we're up to 90. I'm going to end the poll and share the results. Can you see the results? So I'm really pleased to see that the majority of us, 68%, almost 70% have had a vaccine. So that's great. Okay. Let me go stop sharing the results. Okay, the next poll question is, if you've had a vaccine, what type did you get?
A comment on that poll is you don't have all the vaccine types up there. You only have the US types.
Oh, good point. Next time we'll include the, so that would be AstraZeneca, right?
No, there are more than that.
Okay. Clearly, I need to do more homework on this. Okay, so I'm going to end this and share the results. So most people had Pfizer. Okay. Okay, the next poll. This is a two-part poll. So however you define your life's being back to normal, please check off when you think that will be. And then also I had a few people request that we put a poll in as to when people plan to travel by plane. So, okay, we're up to, I'm going to end the polling and share the results. So I'd say a fairly pessimistic feeling about when life will be back to normal, but that is not stopping people from traveling. 56% have said they will travel in the next 3 months. So way to go. That's awesome. Okay, and our final question is on testing. Okay. So let me share the results. Looks like by far the majority feel that testing will be part of our lives. And it looks like people feel that they will want to get tested, not just at work, at large crowd venues, almost everywhere. Only 3% said they don't believe they'll need it. Okay, so with that, thank you all for your input. And once again, thanks to Fred. I am now going to stop sharing my screen, Fred, and turn it over to you. Wherever Fred is. Is he?
Okay, well, I got a message that he was going to be here in 5 minutes, and that was about 5 minutes ago.
He likes to make a grand entrance.
He really does.
That's right.
We need more of the theme song. I don't know.
The good thing that everyone should know is that there is an amazing amount of research and work that goes into every single one of these presentations, literally days and days of work. And so when he is late, it is probably because something came across his desk and he's adding it to a slide or putting it in. So,
So true.
I can guarantee that.
so for that, again, and for those of you at our last meeting, which was January 10th, several people raised their hand. Arthur, Cynthia, Tanya, Bob Poulin, and they have all become part of Team Fred, and I think have been an enormous help. And one of the things that I didn't have a chance to mention is that in this last year, Fred has been doing a tremendous amount of pro bono consulting directly with states, the federal government, and other nonprofits, as well as companies. And so a lot of that information is also getting out that way. But after today's presentation, if you feel so moved, please raise your hand and join the group. There's been just a fantastic outpouring of support and spreading of information. And so having said that, Christine, is our man of the day coming soon?
Yes, let me just give him a call, see what's happening.
I don't know if any of you have been monitoring the chat. Martha O'Mara asked if there are post-vaccine effects. If you've had effects after your vaccine, let us know. Oh, someone said, Tamsin said his life is back to normal. Tamsin, are you dialing in from New Zealand? It looks like you might be, actually. Okay. Christine, you have the slides. Do you want to kick it off? You know what I will do while we're waiting? Let me go back to the slide that talks about. Oh, I think I just saw Fred. Fred, are you there?
I am. How's everyone?
Oh, everyone is just great, especially so now that you're here. You missed your wonderful and glowing introduction, but we are all waiting. And we did some great polls. I have pictures of all of the results so we can feed that to you later. So I'm going to turn it over to you and go ahead and share your screen. And just as a reminder to everyone else, please do put yourself on mute.
Did everyone get all the questions right?
Everyone answered absolutely perfect.
Everyone got the questions answered. Yeah. So we will get back. We will be reviewing those at the end.
Okay. Oh my gosh. Well, let's see what we can do here.
But Fred, I
So-
think that the answers kind of reflect the opening slide here pretty well. I think we're on track.
Yeehaw. Yes, I know. It's exciting. We are getting there, you guys. It is very exciting. I will put on a slideshow. Let's see here. So here we are, back in the day. Ready for spring break. And the question is, is this a good idea or not, given our situation with COVID? And I can guarantee you there's a lot happening down at Daytona Beach in the next few weeks. So, the question is whether it's the right thing to do right now, now that we are on our way back to vaccinations, or maybe that we're not quite done with the race yet. So that's the big question we're having. Is it almost over? We're seeing a lot of that in the press these days. And today there's a lot of mixed messaging. And so I wanted to give you my sense of where I am. And as you know, I'm working with a lot of different governments all around the nations, as well as different state governments. And so I see a lot of differences in the way people interpret data sets. And so I wanted to go through why there are differences in the data sets, and maybe that'll help you, kind of think more broadly about what we're going through right now in this kind of crazy transition period we've got. So the question is, can we predict the winner right now, the virus variants against the human vaccines? And last time I talked to you, I was feeling pretty good about where we were with our vaccines. It was January 10th. And and unfortunately, the week before that, I'm sorry, kind of a couple days before Christmas, there was a Royal Society meeting and a medicine meeting, and in the UK, and they started talking about these variants. And
I want to hear this.
Ben,
can you hear me okay? And normally these people are pretty calm, but in this case they were pretty nervous about the variants, and they'd had a lot of personal. I hear some background noise. I'm sorry, but are we all good
Yes,
for?
Deanna, if you could mute whoever, I don't know who's talking, but I see a few people that we need you to mute. Thank you.
And if we could put on recording too, that'd be great. So, and at that point, I was a little bit more concerned. So I started looking into the variants, and we started realizing there were some variants of concern. And we'll go into those variants of concern, hopefully in some detail, to give you a sense of where the race is going and why people are winning and losing. But the message right now is fairly extreme and contradictory. As I said, I work for different states. Some of these states are opening up and easing restrictions. Other states that I'm working with are actually tightening the restrictions or slowing down. In the yellow, you can see the slowing down of the restrictions. So across the country, without very much pattern, in here, governors are making decisions about what to do with their states. And there's, as I said, there's no kind of clustering effects you see. It's just everyone seems to be easing restrictions, overall, it's finally we got some benefit from all the work we've done with the vaccines, and you'll see that the governments are pretty extreme. So if you're in power, you're saying what a wonderful job we're doing and how you want to show and give back something to the citizens now and open things up. If you're out of power, the government, the governments with the exact same data sets and you looking at the same materials will say, oh, we've done a bad job managing this, and it's a shame that the current government is in place. So there's a lot of polarization around the issue, which is partly the result, I think, of the federal government ceding a little bit too much coordination power back to the states, frankly. And as a result of that, there are no kind of common ways that we're measuring things. There's no common metrics we've got. There are no common infrastructure sets we have. When you talk to the people, and I do a lot of work right now in distributing the vaccines, and the cycle times are all different from state to state. The capacities are all different from state to state. Some of them are on paper, some of them are on electronic capability, and as a result of that, there's very little synchronized kind of announcements of what's happening in the country. The media is very headline driven, and so you'll see on one side of the equation, a certain bias in the media, and versus another side of the equation, and those biases tend to be pretty consistent. Sadly, CNN versus Fox versus NBC versus CBS, there tends to be a fairly, at least on TVs and on social media, you'll see a fairly consistent kind of bias, if you will, about the way we're working on this. And as we said, on social media, that really is carrying the day right now. The social media groups, I think, will decide, have a lot to say about whether people are feeling comfortable or not comfortable with all the vaccines. So what I did is I went back and I talked to some of my friends in the epidemiology world, and I asked them what they thought about opening up and what their levels of risk acceptance were and what they thought. And basically they answered the question based on the activity and their own personal risk level, which is the way you should think about it. What is the activity I'm trying to plan for, and what is my own personal risk level? And you can see some of them based on the activity plan, they were pretty consistent. They thought that they would, are doing things today, but in a curtailed new way. If you're talking about doing things at home, being outside, going for picnics, to some extent, normal shopping, distance sports, those things where people are saying, yeah, I'm doing those today, especially, and if I'm at home and doing my own thing or getting receiving things at home, I'm not going to need any mitigation at all. But if I'm out and about with picnics and other people, I want to have everyone wearing masks. And then it starts to say, I'm not really going to, I want to do these, they're starting to get into the light green and the yellow areas. They're starting to say, I'm not very comfortable getting in a taxi, going to restaurant dining, going to museums, even going to the doctor and dentist, unless it's an emergency, before I get vaccinated. Because I feel like I'm putting myself at some risk. Some people are saying, no, I'm willing to do that today, but it'll be a little bit curtailed. By the time you get to exercising at the gym, going into indoor restaurants, working in enclosed spaces of the office, if it's not very well ventilated, they're saying, I'd like at least to see my colleagues getting vaccinated and being protected. And finally, if they're talking about going to large sporting events, church, traveling airplanes, going to large concerts, they're saying, let's wait until most of the country vaccinated, or I can be sure that the rest of the groups that I'm with are vaccinated before I'm willing to take that kind of a risk. So you can get a sense of where they are along that continuum. And a lot of it was what they came back and said, am I in an enclosed space? How long is the interaction going to be for? Is it with lots of crowds I don't know and I'm unsure of their health status? And is there lots of shouting and singing and having to speak over loud music or drinks with people I don't know? When those things started to be more and more yes, they felt less and less comfortable. And based on your own risk levels, you should be thinking about that as well. It's not so much, can I do everything right now that I want to do? It's more of what's my own personal level of risk, and what are the things that I'm planning to do? And this is the way most of the epidemiologists that I speak with are talking. Now, part of it is that there's an awful lot of unknowns today. It's early days, and there's sort of a philosophy people have. Some states that I work with, they say, hey, if it's not a problem, I don't want to hear about it. Let's go ahead and open things back up until we do realize it's a problem, and then we'll back it back down again. I'm more a person that's going to say, if I don't know something, I want to kind of test gingerly whether the ice is thick enough before I jump up and down and start playing hockey on it. So I tend to respect the unknown, and tend to, and you'll see in this presentation, I also will tend to be a little bit more conservative than others you may be hearing in the media. But I think it's kind of safer, especially given our age groups and given people, given our likely susceptibilities. Over 40% of us have a pre-existing condition that makes us more susceptible, and most of us are up there in age. So I think that I'm representative of the group, and this is the way I would think about things. There are some inconvenient truths that people want to kind of ignore. The first is that we can declare victory over COVID without any resistance from the COVID. The Japanese or the Germans aren't going to complain if we declare victory, but it'll largely be, it may be, if we do it too early, it'll be because we're just becoming numb to a new normal, and that there's push from political and business interests that are causing us to say let's declare victory before it's necessarily true. And the other thing is that we do have real technology breakthroughs, and these technology breakthroughs may well, I think, will carry the day. At the end of the day, they will carry the day. Science is going to win. It's just whether, when we're able to really truly declare victory. My sense is a couple of things. Number one, it's going to take a little bit longer to return to normalcy for many of us than it's currently being reported. And you're seeing, I think Wall Street Journal, Marty McRae said, April will have herd immunity. I didn't know whether it would meant the 1st of April or the 30th of April, but either way, I think that's a little bit optimistic. And on the same day, that was February 28th, they talked to Paul Gurney, who heads epidemiology at Johns Hopkins. Marty is a surgeon there, and Paul is saying, no, we're not going to see, the cure of, the elimination of COVID for a lifetime the same day. So two guys, the same department, same school, same medicines. One was a surgeon, one was an epidemiologist, coming to completely different conclusions on the same day, given the same data sets. So I think it's going to take us a little bit longer, though, generally, than what you're hearing. I think we're being fairly overconfident once again about how slow this virus is to react, whether it's not. I think we'll see that we don't have very much data to really defend ourselves effectively. You'll see that over and over again. The virus is more powerful than we expected in a number of ways. We talked about how difficult these viruses are that are spread through the air, that have high rates of transmission, and that are spread asymptomatically, especially. Those are particularly difficult to control, and it's mutating a lot more rapidly than we ever anticipated. That's a problem. Our vaccines are really impressive, but it is new technology. We're learning more about this technology over and over again with the mRNA vaccines, especially. And I think that they're not going to be quite as sufficient. take us over the edge, we're going to also have to have some behavioral change. It's going to be long-term in order to really, truly reach a point of being protected. I think that the virus still is largely in control today. When you look at our levels of vaccination, full vaccination right now is about 10%. So, it still has the upper hand. We're rapidly gaining on it, but we've got to be vigilant with all our weapons. And as I said, you'll hear that over and over again. Lots of unknowns. It's early days, and we need more data. So here's the kind of pathway that we'll take. We have two big defenses. One is the prophylaxis defenses of our vaccines, and the other is the blocking defenses of our masks and distancing. And you can see that basically in January we had a low capability. We're now opening things up so it's even lower. So we're kind of going up the path. And by summer, we're saying that we will be, and likely even maybe even late spring, May, we will be kind of at that yellow dot. We're vaccinating that rapidly, which is great. We'll probably be up at almost 4 million vaccinations a day at our peak. If you look at the numbers, I was thinking, that back in January when I talked to you last, that we would be at about 3.5 million a day. So it's going to be slightly better than I thought, slightly, but not significant. And then we'll move over as we get more and more in control. We'll move into ability to actually suppress the vaccine. Note that countries like Taiwan, China, Australia, and others are moving through a very different pathway. They've already suppressed the virus significantly. So they only have to do a little bit of vaccination, and they're going to be at a point of actually eradicating the virus. That's a different goal. And we're talking about safety in this talk. I'll be talking mostly about our ability to control the virus, to feel safe, but knowing that it's around and there are going to be outbreaks periodically. We've let this virus go too far in our country and in most countries that are surrounding us and our trading partners to get to a point of being able to talk about eradication, probably in our lifetimes. And so that gives you a sense of where we are, what the path is. And one of the questions is, how far are we going to veer from our red dot to the yellow dot off to the left? How much leeway are we going to be giving the vaccine, the virus, without wearing masks and so on, before the vaccine kicks in and moves onto the green pathway? And it's sort of interesting. We're a top 10 country for deaths still and cases still. Brazil just passed us yesterday in terms of number of new cases. But we're at the same time a top 5 vaccinator. And so there are these conflicting questions: is what's going to win out? Will the vaccine really suppress enough to overcome all these extra cases that we have right now? And the answer is we actually don't know. Obviously, if I knew, that would be great. However, you can get a sense of what happened, right? On we had our first wave. There was kind of a surprise attack of COVID. We weren't ready for it. It hit New York, hit California. Interestingly, already at that point, there were differences in the variants, right? In New York, we had a much more difficult variant to deal with. California, we had the traditional Wuhan variant. Today, we're all dealing with the New York variant. By the way, that's the G family of the D614G variant that is much more transmittable, and that surprised us. And then we went back down again. Things seemed to calm down. June, July, things were pretty quiet. All of a sudden, we opened up a little bit too early, and we, the epidemiologists were afraid of this, but and Georgia said, let's open up now. That started to push things over the edge as a starting point. And by the time mid-July came around, we opened up too early, and the result was that Texas, Florida, California especially drove us into this new peak. That was the second wave. And then we moved back down again to a slightly higher plateau, flattened out, and then we had the big holiday travel wave, and that was a big one because this, the vaccine is seasonal. The virus is seasonal, and so we saw this huge spike, and then it dropped back, and now it's dropping way back down. And note how much faster the drop down is this time than it was before, and that's because the drop downs are also exponential. So if you're at a very high level and you're able to slow the virus down by distancing, which we did after we all got together for Christmas, by by vaccinating, which we see possibly a small input of at this point, and we kind of worked on the seasonality. All of a sudden, we went down much more rapidly than we were expecting. We're right now on the trajectory of the best scenario that we are running, which is great. On the other hand, we also know that that scenario is based on perfect vaccine distribution. And our vaccine distribution isn't quite perfect. We only vaccinate about 80% of what we receive. So we're a little bit, so the curve indicates that it may be a little bit overly exaggerated, and that may be because we stopped testing. We're down, our testing is down 25% between the time that you see at first of the year till today. And so we may not be finding as much. And of course, our positivity rates are slightly high, indicating that we probably aren't testing quite as much as you are, but we are actually executing about as well as you could have expected, given the manufacturing projection of the vaccines and our mobility at the time that we started, which was as you know, on kind of December 20th. So that brings us to today, and you can see there's a big question is, will the vaccines escape, and will that occur, kind of very rapidly when these new variants come through? And there were scenarios that said if they do escape and start to look like Denmark is right now, we could actually jump up quite high very rapidly. Would there be a spring surge and then brought back down again once the vaccines kick in? Or are we going to go right into control and straight down into herd immunity without ever having another peak from COVID again? So those are the kind of the three big questions we've got right now, and they're largely driven by our own behaviors. If we're able to maintain ourselves while we go through the vaccination process, we won't have I don't believe we'll have a vaccine escape of the B117 virus, which will become the dominant virus. If we let things go, we'll see B117 able to replicate very rapidly, create big reservoirs of the virus, and they'll have to work our way back down. If we're able to vaccinate extremely quickly, we'll be able to push into the spring surge scenario, which says, yeah, but it will flatten that back out and push it right back down again with our great vaccines, because B117 is controlled by our current vaccines. So those are the scenarios, and we don't really know. And here's what the modelers do. Because when we don't know something, we model, and basically the models all look at the same 4 or 5 factors. The first question is, where's the susceptible population? How much are susceptible? Then we have the exposure question, how many people are being exposed? Then we move into, okay, given that level of exposure, here's how many people are going to have infected, and then here's either people will die or they will live and survive. The models don't tend to. The exposure question, some are just what they call SIR models, other are SEIR models, and most of them don't talk about post-infection at all because it's already pretty complicated to map all these things. So what we do, we don't know the level of population immunity, for example, right now. So the reason that Marty at Johns Hopkins came up with we'll have herd immunity by April was because he said that for every one documented COVID case, there's 6.5 additional people who are also immune, because we know there are so many asymptomatic patients out there. That was his assumption, and he got very quickly to, of course, herd immunity. At the same time, Paul Gurney said, no, I'm looking at serology data. Serology data indicates that only 20%, in fact, 18% of the people in the United States have been infected asymptomatically. So when I add all that together, it means that I'm looking at probably late fall period of time before we actually hit herd immunity. And even then, we're going to have challenges because this is so endemic in our environment. That gives you a sense of just how big these fans are, how big the spreads are of uncertainty, even among experts. And again, we don't know the viral prevalence level. We have unknown viral transmission attack rates. We don't know the infection rates. We don't understand infection fatality rates yet at all either. Some people say that the infection fatality rates are less than 0.1. Others are saying it's more like 0.7 or even 1.2. And that those kinds of factors, when you start to multiply them all together, you get tremendous what they call spreads in viable data. And so kind of the politicians, policymakers kind of pick and choose who they'd like to decide what policy makes sense and fits their agenda. And that's disappointing, but that's sort of where we are right now. There are kind of 30 major modeling operations in the United States alone right now, and some of whom I work with, and we are getting, I know when you talk to people who are in the middle of the pack, we're all pretty much saying the same thing. But there are people who are doing outlying work right now, making assumptions that are hard to justify. And the only way you can justify those assumptions is start to actually get data sets. Right now, we don't do any serology testing, or virtually none. Very, very small amounts in 15 states. We'll do that as part of the influenza, the yearly data sets. The vaccination levels, we don't know, and we also don't know how effective those levels are, whether that's just whether it's just for antibody clearance, or whether we're getting true long-term persistence in T cell killer T cells. We don't do enough antigen testing right now. We're only doing about 1.6 million tests a day. We were up at 2.2 million just a month ago. We dropped down quite a bit. And we actually, unfortunately, need to be at about 20 million a day to understand what the true prevalence levels. And then we don't do almost any genetic sequencing. Right now, we're doing about 0.23% of genetic of positive antigen tests are coming back and actually being genetically sequenced in the United States. Puts us as one of the top, I think we're number 43 in the world as far as number of genetic tests we're doing, sequence tests that we're doing on a per positive test basis. So that's a big question mark, is what are we really fighting? Are we fighting the B117? Are we fighting the traditional Wuhan? Or are we fighting some new Brazilian or South African variant? We don't understand infection rates very well. That would really require daily antigen testing and contact tracing. We don't understand what that spread looks like today. We don't understand what we call the K factor, which is the amount of spread that occurs through super spreading events and locations and people. And we don't know by antigen testing how many people have actually been infected before and have natural immunities. And the other problem is, of course, we've ignored all the long-term effects. So when we look at the overall modeling impact we're having, I've been reasonably accurate with my models, but it's going to become challenging. And the reason it's going to become challenging is because there's so many unknowns now, and we're transitioning so quickly into different worlds that you can start to see the unknowns plus the lack of data sets that we should have right now to really control the models and give you some points on which you can really hang your hat and tune the models and into them. We don't have that, and those confidence intervals are challenging, especially when the public is pushing you to say, okay, what's the answer? When are we all going to be free? When are we going to be done? So that gives you a sense of what we're struggling with as modelers, to give the binary messages. Yes, it's free to go and go to Daytona Beach, or no, it's not. They're not ready to go to Daytona Beach yet. And that's some of the challenge and back and forth you're seeing right now. Frankly, I think CDC could do a better job of what they're doing. That's part of why they're having the challenges they are. And here's what happens. The challenge is that the virus going up and the virus going down work exponentially. And so if you think about the variants that we're worried about, here's the old variant, the prior SARS, and you can see that it had an R value of about 2.5, and the new one we think has one of close to 3.2. And this is the difference between the number of infection rates you've got in the old environment versus the new environment. And you've got to make assumptions, because we don't actually do the genetic testing that we should, to understand what proportion of the population has been infected by the old virus versus the new virus, and how many people have been vaccinated or how many people have been sick. And all those things come together. And if you are off by just one factor, you can cause you can be off by entire orders of magnitude. And so what happens when you now introduce vaccines to the equation is one of two things, right? Either the vaccine is completely sanitizing and you are able to block both the old and the new variant. But imagine how much off your model could be if you suddenly block only the old virus and suddenly the new variant has become powerful, and you have all these new niches which it can operate in and spread even more rapidly than normal, because it has no competition from the old virus as a result of the fact you've introduced the vaccine. These three slides are really the crux of the questions that we're having today, which are, What is the level of exponentiality in the infectivity rates? How much are our vaccines going to cut them? And will it be done over all of them or differentially? If you can answer those three questions, you'll know the answer to the question that you want, which is when can we all run and have a great time and go on the beach? So here are the 5 factors. How many people get vaccinated, how fast, how good is our data about the variants they are, how well we sustain personal and the non-pharmaceutical interventions. Those 3 are largely in our control, but they influence the other 2, which is how dangerous are the variants and how quickly they evolve, and how quickly the vaccine and acquired immunity will fade over time against the variant. So those are sort of the factors we're looking at, and now we'll look at those factors in some detail through the rest of the discussion. So the vaccines. The first set of questions is, these are different technologies and they work in different ways. And so when you look at the results of clinical trials, you'll see that it's hard to compare them because the regulators have asked different questions about a piece of a piece of messenger RNA that is encapsulated in a lipid versus one that is using an active transport mechanism of an empty cold virus versus one that's encapsulated and with many proteins already there in a matrix. So those are 3 different kinds of technologies. The Novavax Sanofi vaccines are the spike proteins are used. But instead of being put into the mRNA and then letting your body produce it, they actually produce them in their factory. So it takes more time to create these protein-based Novavax. And so you'll see them coming out probably in about 2 months. And I think we'll have at least Novavax on the market by May. So that's another option for you. It's a great vaccine. It'll be a great vaccine. Again, they're working with Takeda. So they got huge capacity again, billion dose capacity coming out of Japan. Japan is really counting on this to come through, and Sanofi is a little bit delayed. They actually use a different technology that requires them to use an adjuvant. And adjuvants, what you do is you create an immune response, and then you tune the immune response based on the use of chemicals. And Sanofi undertuned, so they didn't get enough of an immune response in people over 50 on the first set of clinical trials they did. Now they have to be going back again and redoing their entire set of clinical trials, so they're going to not be available to the middle to late summer. J&J and AstraZeneca are using the viral vector. They're 2 different viral vectors. AstraZeneca uses a chimp adenovirus, and the chimp adenovirus. Of course, there's a question there of whether you have the nice thing about using a chimp is that you don't have any cross-reactivity from human if it gets into you because it's all from a chimp environment. J&J does use a human adenovirus, but it's from a common cold. And so again, when you talk to the regulators, they're concerned about enhancement as a result of using an active transport mechanism. They're worried about cross-reactivity. But interestingly, Sputnik 5 kind of answered that question because it used both the adenoviruses. So there apparently isn't too much cross-reactivity to worry about if you believe the Russian results, which are 92% positive with very few safety issues. And then the Pfizer mRNA we talked about last time, and these are encapsulated mRNA pieces in lipid molecules that sort of slide their way into the cells, and then cells produce the muscle cells then produce an immune response. Interestingly, the adenovirus, those will last in your body for up to 120 days. Versus the lipids and those pieces and the mRNA pieces will be just you'll eliminate those from your body within 24 to 36 hours. Again, the regulator is going to ask different questions about these different kinds of technologies, and these technologies have different areas of advantage and disadvantage. Fundamentally, their job is to deliver this spike protein. The problem is that despite having very different kinds of platforms that are all patented, all special, all different, fundamentally we're all using the same spike protein. That's because we have to avoid enhancement. But it also means that we are very, very susceptible to mutations in that spike protein. If a variant suddenly has a slightly different spike protein, it will escape, or it could escape, the antibodies that are created using the old spike protein that's been injected through the vaccine. And that's the fundamental problem. Here are literally almost every major manufacturer who's using a synthetic, these are the synthetic viruses, not the attenuated viruses, not the killed viruses like you see with polio and our traditional workhorse vaccines, but these new synthetic vaccines. Every one of them is either using one of two spike proteins. The Moderna, Pfizer, J&J, Novavax, and Sanofi spike protein have a couple of prolines added to basically make it more manufacturable. And the AstraZeneca, CanSino, Sputnik 5, Inovio, and Sinovac as well, all use the full spike protein without any variation. So that gives you a sense of, even though it looks like we have lots and lots of different opportunities to really kill off the virus, we're using fundamentally the same antigen, and that is a kind of an Achilles heel, because if you're able to escape one antigen, that you'll be able to escape almost all the tools that we've got, both on the monoclonal antibody side, medicine side, as well as in the vaccine side. So here's and so we assumed when we created this that we would have very little change in the spike protein, because the spike protein is the one that attaches itself to our ACE2 receptor. Almost every cell in our body has an ACE2 receptor, and the viruses find that ACE2 receptor, bind to it, inject our cells as a result through that receptor with their special messenger RNA that cause you then to reproduce the virus. And we always thought that because of that, because that had to be very conserved in order to have that nice nice binding affinity to our receptor, that it wouldn't mutate much. In fact, what we found is that there's the spike protein is actually mutating at twice the speed of the rest of the virus. Very rare this happens. Very disappointed it happened, but that's what is happening. It's and overall the binding region is actually, not only is the spike protein mutating very quickly, but the actual area that's binding to us is mutating more rapidly. That means the binding region itself is mutating 4 times the rate of the rest of the virus. And that means that these variants are going to be pretty slippery. So when we look at this, how is this working? A lot of people say, Fred, I don't have to worry about this virus because my body's going to take care of itself. Well, the problem with that is that that in order to keep up with the virus, you have to reproduce as fast as the virus does, and you have to mutate as fast as the virus does in order to be able to have the same level of response. And we just don't do that, right? And the virus is mutating, is reproducing every few minutes in some instances in our bodies, and because it's only 30,000 base pairs. A couple of small mutations could make a very big difference. When you get to the point of being a mammal, like a mouse, or us like a human, we don't reproduce that much, and we also aren't affected by individual mutations nearly as much as a virus is. The result is that once the virus gets established and can mutate and find new ways and avenues, your body can't respond fast enough to that. And so the people who are saying, I'll exercise more and I'll figure it out and my body will adjust to this, are fooling themselves. They're missing the point of the genetics. You just can't beat the viral genetics when you're a mammal. And so that's what happens, is now we're getting survival of the fittest in a huge gene pool that's reproducing very, very rapidly all over the world, and under very competitive environments. And so we're seeing these family trees very rapidly and exponentially increase based on these mutations. And the viruses are just that much more adaptive than we are. So the only way we can really win is to deny the virus its gene pool, which is all about denying it ability to reproduce, denying it the ability to transmit at all. And that's the way we can. That's the only way really you can win. So if people say, I don't need a mask, my body will adapt. That's a very, the mathematics won't work out for them. And here's the way that we see the spread so far. This is, if you look at this as a geneticist, you'll, it's called phylogenetic dynamics. When you have these long straight lines, though that means you're having a lot of exponential growth. So you see that initially you had quite a bit of variation, and then you had a lot of exponential growth of a few variants that were really coming together. And those are, the weaker viruses, the more easy to defend against would be ones that are much more mixed. So in other words, the reds would be mixed with the blues, would be mixed with the orange. Those are easier viruses to deal with because they've got more things that we can attack. When they're quite focused like that, they're actually quite hard, and they really become quite rigid in just how much advantage is conferred on those particular strains. So you can start to see that initially we had the Wuhan virus. It was very quickly replaced by on the bottom of the page on the left-hand side. You can start to see, Wuhan virus very quickly replaced by the D614G viruses. That's the 20AB viruses. You can see those are the kind of the blue dots and the light blue and gray dots, the gray areas. That's the current dominant mutation in Europe and the United States right now, and that's going to be replaced by the orange ones. And those are the variants of concern, the VOCs they call them. Those are coming up in orange and yellow and red, and those are now we think going to become the next dominant players. And this is all a fight for market share, if you will, on the business side, that they're going after. Now the problem is that as one becomes dominant in one area, you think, okay, it's actually fenced, it's ring fence. That's about as hard as it's going to go. Unfortunately, we get on airplanes every day and we fly around and we introduce these very hardy, very fit variants to the rest of the world. And so the fitter variants then very quickly take share from the other ones. You'll see it's an exponential rate. You'll see it over and over again as we talk. And by the time the variant, now unfortunately, we don't have very good detection systems in the United States. So by the time we actually recognize that a variant is there, it really is there. It's not only there from a point of view of finding, the person who brought it in. We are actually already in the community. So these are people who said, oh, I'm feeling sick. We'll go ahead and, in 1 in 2,000 times, we'll actually do the genetic sequencing, and we'll say, oh my gosh, that's a Brazilian variant. And he said, have you been to Brazil? And I said, no. And then we know that that person must have been infected by another person. And since we don't contact trace, we can't really find out what the spread looks like, where it's going, how prevalent it is. And that really means we're shooting in the dark as far as our defenses go, and whether our vaccines are going to be protective or not. We could tell you right now, if we had the data set, whether you're protected or not. And sadly, we aren't even close to that data set, so we can't tell you the answer. And so people are waving their hands a lot, but they just don't have the data. And we haven't invested in that data, and that's a shame, because we had a year to do this and we haven't done it. So and of course the vaccines now introduce a brand new dimension of it, because we're going to start to cross selection pressures of the vaccine, and we also will not be able to monitor that because we don't have the infrastructure set up, which is too bad. We have the global battle for the gene pool, right? So we have a whole set of human tools, right? We're reducing transmission, we're trying to kill off the virus, and those tools pretty well. And what's interesting about these tools is that it's an awful lot easier to do things on a preventative basis than to let things take off and then try to flatten the curve afterwards. So our tools are much more effective if they're used early and rapidly and quite conservatively than if you wait until things blow up and then say, okay, let's flatten the curve. Then it becomes very, very expensive. And so that's what we're trying to avoid, but we haven't done that well with our 3 surges in the past. Sadly, hopefully we'll get this one right with our new vaccine trick. But the variants also have their tricks. And what you start to see is that it's almost a battle. On the one hand, we're trying to mask. On the other hand, they're going to they're going to start to find variants that are that actually eject more particles for a longer period of time. We're going to then start to do more distancing, more testing, We'll try to contact trace a little bit, try to figure things out, and they'll start to then find higher affinities of binding, be stealthy, and try to avoid the vaccines and medicines that we're putting into us, and so on. So it's going back and forth and back and forth. And right now, I think we have the slight upper hand with our vaccines, which is great. But what the virus is constantly looking for is it's constantly looking for susceptible people, right? That's that S in the first part of the modeling equation. And as long as it can still find susceptible victims, it will continue to reproduce, continue to have mutations, and those mutations start adding up. And if they're big enough and extensive enough, they will overcome our vaccine. So it'll seesaw back and forth depending on how many susceptible people it can find and how transmittable the virus is. And you can see the susceptible people are those right now. Over 100 countries, not one person in those countries has even been vaccinated yet. So we have a long way to go as far as reducing the size of the gene pool on a worldwide basis. On a population basis, no children have been vaccinated anywhere in the world because the vaccines haven't been approved for that. In the United States, children are about 75 million of us. So that's a lot of people to continue to infect. And what we're finding, unfortunately, with the B117 virus is it infects children a lot more than the old Wuhan viruses, and so and the old D614 G virus alone. Now, and so what we're seeing in Denmark is the young children who before were going out and playing and interacting with each other relatively normally became very ill. They gave it to their parents, who were sadly not vaccinated because they only vaccinate people over 65. And now we have huge outbreaks in Europe that are very, very difficult to control because we have a B117 variant that we weren't anticipating, and our old tools no longer work. And the last big area that I'll talk about in a second is the immunocompromised, and that's a big area that we're worried about. So at any rate, we don't have a perfect tool set. Not one thing is fully sanitized. We don't have a fully sanitizing vaccine yet. We don't have a fully sanitizing masking capability yet. We're not testing enough. And so when we don't have a perfect tool set, then we have to start to layer. And this is the Swiss cheese model of protection. And the first thing you want to do is you want to do prophylactic prevention, which is the vaccine. Then you want to start to do physical intervention, and you'll be aware of your own personal risk and be able to adjust based on your personal risk. Then you want to start to distance yourself based on those additional risks. Then you're going to add masking and face shielding. Unfortunately, if you still contract the case, if the virus got through to this point, through the Swiss cheese to this point, at that point, the virus can reproduce, and again, it adds to its own gene pool and becomes more and more fit against those particular, and is selected for those particular capabilities that variant has. As they become sick, then you start to move into contact tracing, testing, isolation, so you can understand spread. We don't do that today. It's a big miss. And finally, if we at that point, we also will start to do clinical management and start to interfere either with monoclonal antibodies and antivirals that actually interfere with the mechanisms of reproduction directly in your body, or we'll try to work with you prophylactically, like dexamethasone and others, to reduce the cytokine response and some of the side effects we're having. And obviously, as soon as the virus is able to transmit, if you die as a host, you really haven't reduced the fitness of the virus because it's been able to reproduce. So that's the way that works. And you can see that now that those were our defenses. So we have blocking particles, we have vaccines, we've got medicines, right? The variants, if you look at the variants and the way they are evolving, is they have moved, as I said, from a D614 virus. You can see in February that was the predominant virus, and then it just dropped like a rock in terms of its market share, because the G614 virus was so much more effective at transmitting. You can see that the 614 basically didn't transmit much. The G614 transmitted an awful lot, and not only did it transmit an awful lot, but it turns out that we started then to add other kind of factors that help the virus, and those factors were things like more sugars around the proteins to disguise them, so it was more stealthy to get into the body. We're seeing a little bit of that, not quite so much. What we're seeing a lot more of is actually enough of a configuration change that our antibodies that we create as a result of the vaccine or as a result of taking convalescent plasma or monoclonal antibodies don't stick as well to these particular particles. So we have, and then when they get to the receptor that they're interested in, the ACE2 receptor, they're stickier. So it's less sticky to the molecules that are supposed to defend us, more sticky to the actual target that they need to find. And that those two things combine then to become a lot more transmissible in the next series, the next round of variants. Then they enter the virus, the cell much more effectively, frequently, and then they actually accelerate the interior cellular machinery to actually cause faster reproduction and faster generation cycles to occur. So they're that much more quick to overcome any enemies that they would find or any other variants that they're trying to fight. So that gives you a sense of the back and forth that we're having with the virus versus what our defenses are. When you look at the whole thing pulling together, you can start to see that what we're doing is we're starting to already to select a little bit for the variants that have these tricks. And slowly but surely, when you start to look across the series of tricks, they're starting to stack the tricks. So what happens is they start to have a gene pool that's full of capabilities of improved infectivity, having gene pools of improved neutralization, antibody resistance. They're having gene pools of increased virulence and coughing and sneezing, and all that. Then when you start to combine, you're not dependent. These viruses are not dependent on a single big mutation. Right? It's not one huge mutation. It's a series of small little changes that occur over time and are convergently selected for on the evolution. So slowly but surely you get stacks and stacks of very, very effective escape genes in a single variant. And those variants go out and they start to become the dominant variant that we're supposed to be fighting. And our old tools don't work very well. And that's what's happened now with masking. It's what's happened now with some of our distancing. It is what may happen with the vaccines, and that's what we're all worried about. What happens now in some special cases, some viruses are able to have multiple infection within a single host. We've actually tested for this, and last week we found out that for COVID, it's not as frequent in COVID that this happens. But what we did see where it's very frequent and what we have to really watch out for is in immunocompromised patients. These are patients that it'll take 100 days, 150 days for them to finally get rid of a COVID infection. And what happens is those people become living petri dishes of selection, and they will slowly get reinfected and come back to the hospital with a slightly different bug, and these bugs will recombine. And we think that's what's happened actually with the B117 variant. We think we can trace that back to a single person who was immunocompromised for 102 days in the Cambridge hospital. We believe that's happening in what may have happened in the HIV-rich area of South Africa. We have a lot of immunocompromised patients, and what happens is these infections, what they call smolder, over a whole series of time. And as that over time, what happens is these stacking occurs, and then these stacks then recombine with other stacks, and you get incredibly fit variants that come out as a result of that kind of a process. And in the United States alone, 10 million people are considered immunocompromised. So that means they've had a transplant, they have cancer, HIV, others where they're on special meds to lower their immune systems. Unfortunately, that's what we measure right now. But if you look at the true measure of how many people are taking immunosuppressants, those are our number, 1 and 2 drug franchises in the world, as Humira and the other immune suppressants. 24 million people take an immune suppressant. So we may be creating an environment where you're talking about a lot of people being able to create these super variants. How much variation is there in the SARS virus? And so what we did is we said, okay, there are 30,000 total genes, where we look at genes that could confer better fitness, improved translation, improved particles, improved binding, improved stealth, improved glycosylation, all the improved protease stimulation, et cetera. We looked at all these different genes that we thought might be able to confer a little bit better fitness. And then we, of those 4,000, there are probably 100 that we were concerned about and we're monitoring. And of those, there are probably about 30 that we've seen so far emerge. And what's nice is that independent, all these very strong variants that you see have evolved against the same selection factors independently. And so we're starting to see the kind of the tricks that they have, and we're thinking that we're getting pretty good at beating the tricks that the COVID has, but there's still more out there. We're still holding our breath. That's sort of what you'll get a sense. We've probably been through about a third to a quarter of the tricks that they have up their sleeve, we think. So what about the vaccines? That's our first line of defense. That's our prophylactic line of defense, and we've got 3 vaccines available to you right now, and you can see the numbers that people have been talking about. 94.8% reduction in chance of having any symptoms after 2 doses, 28 days. Moderna, 94.1%, 2 doses after 6 weeks. J&J, 66% reduction in moderate to severe symptoms. Now, the other 2 these are the first 2, as you know, are mRNA vaccines. J&J is a vector-based vaccine. They decided that J&J had a different endpoint. You're looking at moderate or severe symptoms, and they only needed 1 dose. And they actually did their work during very high viral load conditions, and we'll see the implication of that. But here's the bottom line. The bottom line is that of all these tests, we went through all these clinical trials, we tested 43,658 subjects with vaccine. Only 2 of them had severe cases, and nobody died. That's the real headline. And so if you have a chance, and I've done this for probably 40 people so far, they said, Fred, should I wait for Pfizer, or should I get J&J tomorrow? Or should I get Moderna? And the answer, even for young people who are healthy, who have no pre-existing conditions, has always been to get what you can right now, because what you're trying to prevent is the severe disease or death. And in some cases, the math becomes overwhelming. And if you're talking about diabetics who are overweight, over 65, or you're talking about the difference between having a 1 in 50 chance of dying in the next, if you catch COVID in the next 20 days, versus a 1 in 10,000 chance of dying. That kind of math we're talking about. So for goodness sakes, if you have a chance to get a vaccine, take it, and don't wait around. And we'll talk in a second about countries who made that mistake. So we've got, so that gives you a sense of just how effective how powerful these vaccines are. They are really, really tremendous vaccines. They're better than any of the vaccines I worked on in my career. Here is the differentiator. If you want to see, this is the Kaplan-Meier analysis, and basically it looks at the separation of cumulative deaths. If you have taken a placebo, which is in the Pfizer case, the blue, or whether you've taken the vaccine, which is the red in the Pfizer case. And you can see a nice continuous line after day 12, continually going up, of people who are getting infected when they are on the vaccine, and almost no continuation of disease or infection when you're on the vaccine for Pfizer. And so when you add up all this, you see that's the number they got with 95% effectiveness. Now, Pfizer, so that's Pfizer. Now for J&J, they said it's only 66% effective. The issue, and 72% in the United States. These are global data sets, so they include South Africa, they include 5 different countries, excuse me. But they include a lot of different countries. Pfizer was a little bit simpler. And Pfizer was looking at mild to severe, and J&J was looking at moderate to severe. The difference, though, was if you look at the curve on the Pfizer curve, look at the steepness of that curve. It's not very steep. The difference when J&J was doing their trial was they were doing it in the middle of a huge pandemic outbreak in South Africa. So they had an incredibly steep curve, and early on, we know we're not protected. We know for the first 12 days, every case it could be equally a placebo or a control or a vaccinated person. because you're not protected even with the vaccine. So you got a huge number of people early on in the trial who we didn't really expect to be protected in the J&J, which we didn't have in the Pfizer. And so you're looking at apples and oranges when you're talking about the actual testing conditions. They also look at completely different clinical endpoints, mild and severe versus just versus any kind of symptom at all. And we're not that concerned about sniffles. And of course, the regulators were asking these groups very different questions because they used fundamentally different technologies, and they had different concerns about the safety and the efficacy of these vaccines, because J&J is using an already proven technology, so there was some understanding about that technology, and they knew what to ask where they had problems before. With mRNA vaccines, they didn't know what to expect, and so they had asked this whole series of different questions about and have different sets of hurdles to accept. And so that's why when people say you really can't tell the difference between these two vaccines from the clinical trial, that's not just fluff. That is actually true. We don't know which vaccine is better or worse. And this is something actually that governments should do, because the J&J vaccine is $10, and the Moderna Pfizer vaccines are $35 to $40. And so, countries should actually know what the price performance of these drugs are, and they should require tests to be done to find out that. So they have a head-to-head test of J&J versus Moderna or Pfizer. We can do that in certain countries. We can't do that here because obviously all these are already on the market. We can't expect people to do placebo-controlled trials where things are already on the market. But you can do it in certain countries, and our time is getting limited on it, but we should do it. And so here's the actual overlay, and you can get a sense of just how much off the curve Pfizer was versus and the J&J environment was versus the Pfizer environment, and the degrees of separation you can see are quite similar. So we think fundamentally these are two very good vaccines, and we think now J&J is moving forward with a second dose, and Pfizer and Moderna are moving forward with a third dose. So we're going to find out whether even more protection is conferred on second and third doses, especially with regard to durability. You should know that by the end of the summer. So what happened in some countries? In some countries, and I told you about people who came and said, Fred, should I take one now or should I take one in 3 weeks? And I told, we did all the math, and it turned out better to take one now. Well, Germany went through the same thing. And it said, we're not sure about this AstraZeneca mRNA vaccine. We prefer the Pfizer vaccine. And so we'd like to slow down our vaccination and put all sorts of questions in people's mind about whether the AstraZeneca vaccine was a secondary vaccine that they shouldn't be getting. And as a result of that, you can see that Germany's vaccination rates are only at about 6% right now. I'm sorry, that's 6% fully vaccinated, about 8 or 9%, at least partially vaccinated. Ours are closing in on 30%, 26, 27%. UK is at 35. The UK and the EU had a chance to prove this vaccine at the same time, and UK did, and EU did not. And you can see just how what a disastrous result this has had. Because basically what they did is they sweat it. Basically, Germany saying, well, it's 20% worse. Well, the problem was they looked at a kind of they were looking at a 20% worse situation for an order of magnitude problem. They accepted having a 50-day 200 death rate of 200 people a day, and they could have had that 50-day period be no death rates, just because they wanted to wait for a slightly better, what they thought was a slightly better vaccine. So get vaccinated now, and don't make the same mistake that Germany made. In Detroit, we almost had the same issue. The mayor said, we want to have the Pfizer vaccine that's made here, it's a better vaccine. And luckily we quickly stopped that. Otherwise we would have had Detroit also on the same path of waiting for 20, 30, 40 days. While we're accepting a huge death rate in the population, just as we have a chance to push down that curve. So you can get a sense right now, this cost directly to Germany at least probably on the order of 2,000 to 10,000 lives for these last 50 days. It's going to take them months to catch up and get back on the right curve. So the overall impact plus the vaccine hesitancy they caused we're talking about well over 10,000 people dying as a result of that bad mistake they made. And you can get a sense of what this looks like. So here's what happened in Europe, and you can see we're in green, and Europe is in yellow, and you can see that basically we are on a very different curve right now than Europe is. And the problem that Europe had was not only did it delay some of the vaccines, they're slower vaccine than we are, but it also had a bad variant. And this gives you a sense of just how the variant can come in and really change the acceleration. So you can see they started at a much lower level than we did, but how high that acceleration went because the new variant, the B117 variant, was 50% more infective, and it was about 20% more deadly, unfortunately. And as I said, it infects young people at a much higher rate than the old one does, than the original Wuhan and the G614 variant does. So that caused them to be on a much higher acceleration curve, but then it came down again, and then they had this. Then they had the stoppage of the vaccines. Notice how the slope of our line goes almost straight down, and that is a factor of just the fact that we were able to control the virus. We think now the vaccines are starting to kick in as of the 1st of March. We're starting to see the vaccine plus the number of sick people we've had who've recovered start to kick in now and make a difference. Unfortunately, you can see we're now plateauing, and we're plateauing at a higher rate, 70,000 death rate, new case rate a day, than we were back, in the summer or even in November. So that's disappointing at the new plateau. That means that we're having a lot of bubbling that could occur and could jump us right back up if we're not really vigilant right now and getting all those vaccines out. The problem with the new variant is that not only does it kill you, faster and cause a lot more sicknesses, but it also, because it's more transmittable, it actually raises the amount you've got to actually vaccine and protect yourself as far as getting to herd immunity. So our old herd immunity target was around 75%, and our new herd immunity target is probably over 85% because it's 50% more infectious. If the vaccine stops it, then that stops the transmission and of the virus. We won't have this problem. But if it doesn't, we'll have a higher level of herd immunity, a higher level of number of vaccinations we'll have to have in order to beat the vaccine. So what you'll find is when you move into these new variants, you could have gone to the grocery store without worrying too much about it, hardware store without worrying too much about it, gone golfing with your friends without worrying too much about it. Those old behaviors suddenly don't work with new variants, and as we get as we get beer muscles, when we have or we're partially vaccinated and think we're safe, these new variants can come back and kill us. And the problem is that if you look at the hesitancy. If we're hesitant right now, that causes a much longer delay because it allows the establishment of new variants, right? So if you look at the curve, you can see that we start to hit herd immunity kind of early 2020. This is for Europe, and now Europe is probably delayed into late 2022, because it not only has to reach a higher level of herd immunity because it allowed this new variant to get established. So. That's some lessons. I think now we're actually ahead of Europe. In the past, we were behind Europe. And so before we used to kind of use Europe as a benchmark, we shouldn't do that anymore. They should be using us as a benchmark. Now, vaccine hesitancy in the United States is declining, which is a great thing. Right now, overall, we're expecting an overall attitude shift of about 24% from January 1st, 2021 through the end of the year 2021. That's the projection from the ad council as well as a few other groups. We're finding that the Black communities are just as willing to take vaccines now as the white communities, which is a huge amount of work that people have done in the field to achieve that, and it's really great to see. And you can see that we're getting to a point of having probably about, we think overall we think we're going to get about 75% of people vaccinated in the United States I think that's right. What did I get? I think I had 57% were going to get vaccinated, and then another 20% would be would have immunity from infection. So we're at kind of 75%. We're at where we needed to be before, and unfortunately, with the new B117 variant, if the vaccine doesn't kill it off, or only partially kills it off, we're going to actually have to be even better than we had planned to be in the past. And so we need to actually have more carrots. We need to advertise the fact that if you get a vaccine, you'll have access to more venues, you'll have access to more events, you'll have access to more activities, maybe even your job will be an easier one to have, because otherwise without these vaccinations, you'll have to be tested a lot. Kind of every 2 days. Access to schools will be easier as well. So you can get a sense of that. And we'll talk a little bit about average levels of immunity versus precise levels of immunity that we also need to figure out a little bit later. But that's going to be an important factor to think about overall herd immunity on average versus what it's like in your community. Knowing those two things is very important when you're managing your life. So here is what happens in Texas. So this is a work that actually DSmart out of Deloitte did, and because they asked the question, what happens if Texas opens up? And the answer was, thank you for this analysis, by the way, it looks really weird, right? But if they start opening up completely in Texas on April 15th, they're going to have a huge spike, a very, very large spike that'll come right back down again, but it'll be big. And that assumes that at the current level of vaccination rollout, projected vaccination rollout, which is getting better and better every day, if you wait and say, well, now we've rolled out enough of the vaccines, let's wait and now let's open everything up on June 1st, you can see you still get that little bubble. The only really way to get to a point of feeling comfortable is basically waiting until September. And you need to wait basically into the fall to relax social distancing completely. Otherwise, you're going to get these funny spikes. And what's interesting is if you start to look at what happened in Europe, and then you look at the early lifting scenario, you see that very high spike, which is very similar to what we're seeing in Texas as a one-shot deal. So what you start to do is you start to say, well, what happens if you start to have, Texas's, the EU is 26 other states. So if you start having Texas's in the EU, which they did, at different rates, slightly offset from one another, when they open things up, when they loosen things up, when they tighten things back on again, you start to see a pattern that gets very, very similar to what Europe actually experienced. And that's what could happen to us if we don't be careful in this next 2 to 3 months. So the issue we have is that there are actually 3 different parts of effectiveness. So when we talk about clinical trials, we're talking about clinical efficacy. And efficacy is different than real world effectiveness. And real world effectiveness really deals with 3 different things that are related, but can be quite distinct. The first is that you can reduce the pathology, and that's what we tested for, right? We said, did anyone come back with mild to severe symptoms? If you did, let us test you. And we take a look and see if you were vaccinated or not vaccinated. So we know with some certainty that we're very good at reducing the pathology of the disease. And so it really can protect the vulnerable. The next big area, though, is does it reduce transmission and spread? And for that, we're using real world results, and the Israelis have done some interesting work. I'll show you some of that work and why we're still in the preliminary area of that. And then the last big area, and the most important one is, can we protect enough so that the virus can't find anybody else to reinfect? Because every time, if the virus could be very good with pathology, but not reduce transmission. It doesn't happen very often. I think there's a relationship. It's probably close to about 70 to 80% in this case between the two, but we still have to prove that. And then the next question is, even if it reduces transmission, if every person comes out after they've had the disease and had the vaccine to be still completely susceptible, then you're going to have huge gene pools and huge opportunities to reinfect and reproduce and cause the variants to continue to recapitulate. So that's the differences between when people tend to think, oh, it's super effective. That's not the same thing as clinical efficacy, which is what we're testing for real world effectiveness actually takes a little bit longer to determine. And we're in that awkward transition state of being able to say, here's what happened in clinical trials versus here's what happens in the real world. So when you put it all together, if you have one but not the other, what happens? And the answer is that if you can reduce the disease pathology and efficacy, but you're still allowing transmission and spread to occur, then what happens is what ultimately you want to do is you want to protect your vulnerable, right? So you can have lots of colds and sniffles, but everyone who's over 65 and has diabetes and so on has been vaccinated and they won't die. So you have the continuation of the host and the continuation of the variant. This puts you in a little bit of a tricky situation. It's pretty good symbiosis, but it also means that you're always a little bit at risk of having large endemic populations of virus suddenly mutating and giving you a hard time. And so what you want to do in this case is you want to have you actually want to create vaccines for variants and keep the variants down. That's what we do for influenza. Now, if you have something that actually reduces transmission spread, then you actually want to try to control COVID, and that's our goal, right? We want to actually get to the point of transmitting. And here what we're doing is what you want to monitor for is you want to see what is the viral presence, what's the prevalence level, how much community spread do we have, that's contact tracing. And basically, if you do that for 3 or 4 years, you really understand a lot about how effective your vaccine is and when to boost the same vaccine over and over again. So you re-up your neutralization capability of the virus. And so there, and you'll see right now, Pfizer and Moderna and Novavax, they're all testing boosters of the same vaccine. That's the first line of the next defense. Now, if you're able actually to protect against reinfection, then you want to, in order to determine that, you're actually going to have to monitor reinfection rates, neutralizing antibody rates, the viral variant rates, and all the genetic code. You'll have to do a lot of sequencing. And that, then if you're able to do that, what you want to do is you actually want to vaccinate all the children and then give the children boosters when you see variants come out. And you want to have a universal coronavirus that really suppresses not just this coronavirus, but the next series of coronaviruses. So that's sort of the next series of research that we're going to do as a society. And what we're missing is that middle level of monitoring. We're not doing any of that monitoring. So it's very, very hard for us to determine what path we're on and whether our strategy is going to be successful or not. And we should, I'd love to see us really invest in this infrastructure. I've been saying it for a year to all the people, but it's hard to get people to hear the message. But if we had that, we'd have the website. How are we doing for time? I'm sorry. Are we good? So at any rate, so I just want to talk about Israel quickly. Israel did a quick set of tests. They did a real world test. This is a look at reduction in transmission. And you can see that basically they said, look, we went from 166 per 10,000 people to 6 per 10,000 people. Isn't that great? That's a 96.4% effectiveness rate. The problem was that the two sample sizes, because it's real world, weren't treated the same way. If you did not have a vaccine, every time you got in your car in a taxi or went to a venue, went to a public event, you'd be tested. And if you had a vaccine, you'd flash your green pass and you'd say, I'm all tested. And they'd say, okay, that's fine. So what we found was that we actually reduced this. We reproduced the exact same thing we did before, which was, are you protected from even minor infection? And the answer is, yeah, to a level of 94%. So sadly, we recapitulated what we already knew, but there was some suggestive evidence that we're reducing transmission. And if you kind of correct for all the sampling error and so on, which is hard to do, we think we're in the kind of 80% range from the 92%, which is a great outcome if it's true. Now we're starting to do really much more definitive tests in the UK and the EU on this. We're actually going to we're going to actually do challenge testing, which means we're actually going to expose people to various levels of infectivity in controlled environments. They'll be young, they'll be, some will be vaccinated, some won't be, and we'll see the difference between what's required to transmit and what under conditions of vaccination versus not. And that's a definitive test, and then we'll really know. But right now we're still flying a little bit blind. There's some suggestive evidence looking good though. But the problem is looking good when you're talking about an exponential curve. man, small changes in transmission make a huge difference in the ultimate case rate and death rate. And again, in the absence of data, you really have to be more cautious because you have to over-respond early and then back off. Otherwise, if you get involved too late and you're already working with 1,000 deaths, then at that point the new variant has really established itself and is reproducing and finding new variants that are even more fit than the old one. And so that's why that's the problem we're having at a policy level right now, is people don't understand that these small signals that say we have a slight increase in death rate, which is a very late indicator, or small increase in case rate, when we have these variants getting to be this much in the mix. When that signal starts, you've got to really intervene immediately. If you don't, you're on a pathway that's uncontrollable. And if you think and wait for a minute more, you say, I'll wait. Let's see what the data does. And let's wait another day. And all of a sudden you go from 2 to 4, 4 to 8, 8 to 16, 16 to 32, 16, and you say, holy cow, now my response has to be different. Let me think about it again. Then it's 128, 3, and so on. And it's off the page. So you have to have these environments set up so that you see the signals early enough to be able to respond. And we just don't do that in the United States. We are doing that in the UK. We are doing that in Taiwan. We are doing that in a number of other countries. It is possible to do this if we just haven't invested, which is a shame. And here's how it really looks. So if you don't believe that's how it can look, this is the replacement of the B117 virus versus what they call the wild type. And you can see that it was 1% of the total population, in about October, and by middle of December, it was by far the variant dominant player, right? And you see that exponential curve just taking off, and that was despite the fact, by the way, that they had new distancing measures, they had single dose vaccination in place, now they're talking about even mixing the vaccines. They want to go so much more fast. They have dedicated COVID hospitals, and despite that, the R0 increased 70%. So that's how big a difference a variant can make, and why we have to monitor this and really be watching for it in your own life. Now let's talk about escape. So this is reinfection. And as I said, the reinfection is even worse because if the virus can find what they consider completely susceptible populations after the person's been vaccinated and has antibodies, then they have complete chance to reproduce within the entire population and gene pool. And this is what happened in Manaus, Brazil. They had 75 well over 65% of the population had the coronavirus first round. And then 9 months later, 90% of these people who had been infected in the past got the new variant, the 1351 variant, and that's because the new P1, the new P1 variant had the N501, as they call the Nelly mutation, which causes it to bind much more closely to the ACE inhibitor. They had the 417 mutation, which allowed much more rapid transmission rates, and it had the E4 the E mutation, the 484 mutation, that basically allows you to escape the vaccine's antibodies. So you can get a sense of just how scary it gets if you think you're protected. You go ahead and you don't protect yourself anymore.
Okay.
Then
I'll get it to you, I promise.
Oh, I appreciate that, but if you could mute, that would be good.
Okay. Is that anything else or just your?
Can you mute?
Sorry.
Okay, I'm gonna.
So at any rate, you get a sense of just how, if you feel like you're protected, you go out and do all the things you think you want to do, and you find out you're susceptible, this is the kind of result you can get. You can move from 65% people thinking they have herd immunity to 95% infectivity rates. And right now, Sao Paulo, Brazil, is just overtaking the United States in deaths per day as a result of making this mistake. So here are those three variants we talked about. This is the B117 virus on the left, the B1351 virus that's from South Africa in the middle, and the P1 lineage that we just talked about in Brazil. And you get a sense for the exact number that we think are in the United States. And if you believe these numbers, you're crazy, right? Because all we do is not, right now we are only monitoring 0.23% of all positive tests that are occurring in the United States. 0.23%. So, you know, chances are there's a lot more of these variants out there than we're aware of. And so, you know, we're finding out very late that these variants are, that we have exposure to these variants, and that's dangerous because we're not sure what the future is going to look like. And there are two different kinds of scenarios, right? The first scenario says that we have current variants and the B117 is going to come in and it's going to dominate those variants. And what's going to happen is these variants battle each other. And the question is whether the B117, because it's so much more transmittable, is going to beat out the 1351 or the P1 variant. The P1 and the 1351 are much more dangerous to us because those escape our vaccines. But if the B117 dominates and we're able to then to inject everybody, well, the B117 is by far the dominant group, and we're able to stop transmission. And the P1 and the 1351s can't find new hosts. All of a sudden, that means we're going to win this war. That means that, you know, vaccines and seasonality will eliminate, because we know that we're out against B117 virus with our vaccines. It will eliminate the COVID. Now, in the United States, being United States now, and that's going to change as people travel and so on, but at least we'll have a chance of really pushing us down significantly. Scenario 2 is a different scenario, and that says that what happens is the B117 virus doesn't win against P1 and B1351 in time, and it doesn't replace them, and so we have an awful lot. And then what happens is you have this mix of us helping we're going to kill off the B117 virus, help the P1 and 1351 viruses, and those are the ones actually that could become superbugs. Those are the ones that really could become super resistant to us. And we're also seeing a bad variant out of New York that we're also extremely concerned about. And for people who are in New York right now, they should really be careful and be monitoring and be monitoring the where was it? Oh, I went the wrong direction. Apologies. Be monitoring. It'll be called the B1526 variant, and there are two parts of this for the New Yorkers. The first, basically, we can find out that the variant exists, so we're actually able to do a lot more sequencing of this variant than most. It actually has in our PCR tests. A part of the test will be missing. The S gene will actually be the spike protein detection will actually be missing, and so we know, that one has the mutation that we're interested in. It has the EEC mutation, and so we actually test those. And what we're finding is that 40%, right now New York has 40% 1526. Of those 1526, half of them have 484, the E484K variant. And that means that if you have 3,000 new cases a day, which New York has right now, you're having about 500 new cases of E484K variant every day to the level that we're able to detect, which isn't very good. You know, New York, Connecticut, all that East Coast area really has to be careful right now to avoid having this particular mutation get established, because if it does, it'll be there. And if our vaccines can't stop it, then you're going to be waiting until you know, September to be protected when we finally get the E484K mutation vaccine available. And you'll have to go through the whole process again of waiting and doing the Hunger Games for getting your next dose of vaccine. So watch very carefully for that. You can get a sense that here are the different variants that are coming through. We talked a little bit about New York. Here's the result on neutralizing antibodies. You can see that if the former against Wuhan COVID, which is what we developed the vaccine from, that when you had B117, you had about a 45% reduction. When you went down to South Africa, you had a 72% reduction, or that 82% reduction, excuse me, and then we had a 77% reduction on the Brazilian capability to neutralize. And this, we think, is still just in the cushion, what they call the cushion of protection. We don't know what they call the correlation of protection. We're trying to find that out desperately, understand just how powerful the antibody response, neutralization response has to be in order to correlate with some level of protection. Because we don't know that, it's going to be hard to approve vaccines. That's what we do for flu. We understand the correlation of protection. We say, therefore, we can expect this level of protection. Therefore, it meets a baseline of protection, and we can approve it on a regulatory basis. It passes the risk-benefit analysis we do. In this case, it's going to be hard to do that, and we'll be a little bit slower on the regulatory approvals of these new vaccines against the variants, and that's too bad because we need them right away as fast as possible. You can start to see these slippages are concerning, and as a result of that, manufacturers are all moving to Plan B, and Plan B is each of the manufacturers right now is developing a booster shot to what they already have, so that's the same. They're going to test whether a third shot in the case of if you've taken Moderna or Pfizer, or a second shot in the case of J&J is more effective and lasts longer, more durable than the only 1 and 2 respectively shots. Moderna and Novavax are developing a flu COVID bivalent platform. So they're going to try to actually create a platform that they're thinking you probably will have to go to annual shots. If you're going to get your flu shot, you're going to go get a COVID shot. It'll be protective. Moderna and Pfizer are of course, both looking at, Moderna and Novavax are both looking at bivalent vaccines that allow us to look at, separate out this variant from that variant and add various different antigens. Right now, for example, in pneumonia, we've got 23 different antigens on our pneumonia vaccines. That gives you a sense of just how polyvalent these vaccines can get. And of course, the New York Academy of Sciences, we got together and we decided we would recommend extending the global flu vaccine development infrastructure to COVID. That's on a global basis. We wrote to WHO and said we think you should open it up to COVID. And we also recommended and the FDA approved influenza-like licensure pass. So we're starting to get to a setup for annual, for these variants can be suppressed. Our technology is good enough. But the compromise is where the vaccine is also pretty darn good, and we're probably going to have annual shots. I at least plan for that, and then if it turns out they're good for 2 years, 5 years, hopefully for life, then you can back off from that planning. But I would plan if you've had 2 shots, you probably want a third. In the case of Moderna and Pfizer, and if you had 1 shot, you probably want a second for Johnson & Johnson, at least in September through December timeframe. So here's what the cycle would look like in terms of development, and you can get a sense of, you select the variants. It takes us about 2 months to do that. You develop the antigens. It takes us about 65 days or so to do that. Sometimes it takes up to a few months here, depending on how difficult it is. But generally for mRNA, we're talking about 65 days or so. And we go through about a 300-person trial. Remember the past trials we had were 30,000, 20, 30,000 participants, and now we're talking about only 300, and that assumes that we understand much more about the correlation of protection. We're trying to find out more, and then you get a supplemental licensure. Already you're starting to manufacture, you're right, and so to give you a sense of where we are right now in our cycle, they're developing the antigens right now. Moderna's already announced we're ready to look at this antigen. We're doing phase 1 testing on it right now to do the bridging studies for the trials that we're going to need. So right now we're in March, we're developing the antigens. We have to make a decision to do manufacturing kind of in the June timeframe in order to hit the seasonality that we want. And then we have to start scaling up and doing quality assurance and set asides and do QA release. Takes another 6 weeks. So that gives you a sense of just how, if we know today that we're having trouble with variants, it's going to take us 9 months to really, as little as 6 months, but more like 9 months to really get ourselves ready to go. And this is the way, if you're in a pandemic situation, then you don't want to go for a supplemental licensure. You want to actually go for an EUA, which we're doing now. That's emergency use authorization. You can get a sense that instead of having to, right now, we would be ready to go in 6 months. So this is a 6-month cycle. You can see that the vectors take a little bit longer to develop, and the protein subunits possibly even slightly longer than that, because you have to actually synthesize the vector and have to synthesize each of those protein subunits. That takes a little bit longer. So I think that unless we get some improvements in the development of J&J and some Novavax's timeline, they're going to be challenged to keep up if the variants are really super strong. If they're on a yearly cycle, J&J can easily keep up with that. Novavax and Sanofi probably have to work on some of their production capabilities, but probably can catch up again. So we'll still have, at least 2 vaccines that are capable of keeping up with the variants, and probably 4 or 5 types of technologies. So that gives you a sense. Now, what happens here is that unfortunately, the rest of the world suffers, right? If you have a sanitizing vaccine that you just give once, then you move up a curve, and every cumulative vaccine is for your lifetime. And so you very quickly can go to global herd immunity. That'll kind of take about 4 or 5 years, probably about five years if we're lucky and have the kind of support we need. But if after every year you've got to resupply and re-inject with the same vaccine, then it takes you a lot longer to achieve that herd immunity level, and you come out of it every year and you've got to re-inject. So that requires a much more substantial supply chain. You've got to repeat it with similar vaccines over and over again. And the worst situation is where the variants are so tough, it looks like the flu, and every year you've got to develop a brand new vaccine, which means you come all the way down the curve and you've got to re-inject all the way up the curve. That takes that means you're injecting 7 billion people, well, 6.5 billion people every year. So that takes probably 10 years. And while you're working your way up the curve, of course, you've got lots and lots of pockets of people who are susceptible. And you're going to have many more variants coming out and a lot more risk for even those people who are vaccinated. So if you're on annual vaccine cycles, when annual vaccines are required and they're brand new, you can bet that we're going to have a lot more outbreak. We're going to have a lot more to worry about from people coming in from other countries who actually have reservoirs of extremely powerful new variants that are coming in to visit us. So it gives you a sense of the different kinds of futures we can have under different scenarios of vaccine effectiveness. Now, just very quickly about drug resistance. And, if we look at antibiotics right now, we're on cycles that can be as little as about a year long, and we suddenly are finding that these bacteria that the antibiotics are fighting become resistant that quickly, and that has a variety of reasons for it. But I wanted to point out that basically vaccines have have had a much better capability of maintaining their effectiveness over time, and avoiding these superbugs and avoiding the resistance. And there are a couple of reasons for this. And the reason that antibiotics become very rapidly ineffective and they frequently get superbugs is because the antibiotics basically target one chemical pathway in a cell. And usually, so you have a very low number of targeting sites that you're looking at. It's looking at trying to stop one chemical reaction, one biochemical reaction. The mosaic, what they call the mosaic of protection, the number of different protectants and angles you've got to fight are quite small. The level of selection you've got gets pretty high because you've got lots of different serotypes that very quickly mount up that in order to avoid the antibiotic. And usually you apply this when the disease is already at its peak, right? At a very acute phase, you say, oh my gosh, I feel terrible, I'm gonna take my drug now. With traditional vaccines, those factors are completely different. The traditional vaccine exposes this immune system, a long-term immune system, to the entire virus, right? It's either an attenuated virus or it's a killed virus. It feels all the different proteins. It creates a large milieu, a large set of mosaic protections. It can't. The virus doesn't have that many different serotypes to move to because there's so many that have to be simultaneously attacked, counterattacked, that it can't. Usually we give the vaccine prophylactically. You don't wait for people to get sick and then give them the vaccine. You're talking about very low levels of titer in the community as well as in the body, and of course you're going after very conserved targets, usually the spike protein of the pathogen. If you look at the mRNA vaccine, remember, this is a brand new technology. We haven't really used it yet. And so if you look at that, it's quite a bit more focused than just the spike protein. And so the size of this mosaic protection is quite small compared to using full virus. We don't know what the level of variability is, but it looks like in this case it's quite high, in this particular case for COVID. And we're doing this in the middle of a pandemic when it's almost not even prophylactic anymore. It's almost immediately going to be used before we can really get our immune system up and running. And the conservation of the antigen and pathogen target is quite low in the case of COVID. It means that the mRNA COVID vaccines may act quite a bit more like our antibiotics than our traditional vaccines. And we can see that there are a few of them like pertussis, which had a serology issue, pneumococcal pneumonia, hepatitis B virus, had the mosaics were too small. What we're seeing, and influenza, of course, is an annual vaccine. I think we're going to have a much more an annual type of vaccine type of environment than we would normally expect from a traditional vaccine for COVID. I may be wrong. As I said, it's a new vaccine technology. We're still learning a lot about it, but there's some suggestive evidence about the characteristics of what you're protecting yourself against and what an antibiotic looks like versus a traditional vaccine that would cause me to think that might be the case. The other gap that we're having is in vaccinations, in addition to very fast duration cycles, is that the gaps of vaccination are also occurring in clusters. And the reason these clustering are occurring is, first of all, legally. I work in different states. In fact, one state I work in, actually 3 states I work in, are considering bills that actually would protect anti-vax rights. So if you don't want to have a vaccination, you can't be forced to have a vaccination under any circumstances, with very few exceptions in these laws. And those are growing in popularity. These laws are being rolled out now. Second big thing is, of course, we've got different policy gaps, different kinds of leadership, different kinds of value sets. Some of them are occurring at a regional level. We have 64 separate jurisdictions, each of which is its own country, different reporting relationships, different metrics, different policy makers, and people in power, parties in power. And so you get a lot of separation between vaccination styles and amounts in each of these different states. And then we've got the socioeconomic cultural clustering gaps, right? Where if you are an Asian and clustering more with your Asian colleagues, you generally be protected, we think, at almost a 90% rate, whereas if you're with your white colleagues, it'll be less than a 70%, less than a 70% rate. If you're playing bridge among your 85-year-old friends or 65-year-old friends, they'll be 85% protected. If you're playing frisbee with your with the 18-year-olds, they'll be less than 60% protected, and so on. So you get a sense that people cluster based on these things. They cluster based on their state. They cluster based on their policy. They cluster based on their socioeconomic cultural wants. And as a result, when we talk about herd immunity and we say it's 85%, what happens is that is average. And so this is an actual story about Oakland County. It's in Michigan. I put the arrows in the wrong spot, but basically you can see at the highest level, we've got very big differences between the amount of vaccinations that are occurring country to country on a global basis. And then even within the United States, which is all green, it's looking good, we see that there's quite a bit of variation in spots, right? It's gaps. And what happens is that the virus exploits these gaps. It says, okay, those guys are 100%. Those guys over there, they're 100%, resistant to my attack. But I found a little community over here where they only have 30% protection, and you can bet they're going to find that. And that's exactly what happened in Oakland County with measles. Where we thought we were fully protected. We looked at the county level. It's the third wealthiest county in the country. And then we moved to the congressional districts. We said, oh, it isn't quite as solid as we thought. Then we moved to the school district level and we realized, oh, we've got quite a bit of non-protected environment there. And we got down to the census tract and block groups, and you can see that there were certain blocks, in spite of the fact of having 95% injection rates overall in the county, that there were some blocks that had less than 20% actual protective levels. And so this average herd immunity can really hide the fact you've got huge gaps, and you can bet that the virus and especially the variants are going to find those gaps. And so what we need to do is we need to create an infrastructure that allows us to really look at and create at a global level what's going on at the antigen level. We have to do much more antigen testing at the home and do much more work with surveillance. Sorry about the E getting shifted over. So we, antigen levels, serology testing, zoonotic surveillance, and finally genetic sequencing all allow us to know a lot more about what to protect, what vaccines need to be developed every year. And that has to then move into a situation where we've got scaled pilot manufacturing and adjuvants and all the supply chain ready to go. And right now we don't have that kind of an infrastructure. We don't have a pandemic response infrastructure in place. And until we get one, I think we'll all be at some level of threat. So, and this is something the United States could do.
Fred?
Yes.
This is Jean. How are you? This is fantastic.
We all done, or you want me to stop?
No, can I just say something here?
But we've had several texts about long haul effects.
Oh, okay.
We have some slides on long haul effects, and since we're getting close to the end of our time, I'd like to make sure that you cover those.
Okay, let's do that.
Yeah, Fred, you're doing great. That's just one section left, really. So I hope you guys can hang in and hear it, because it's new. It's really new.
So the long haul, well, they're not that new. Just the first time we're talking about it.
But your slides are new.
Oh, the new, yeah, it's true. All these. So this is basically Pfizer's thoughts about how to go after the virus. And you can see our medicines aren't terribly effective. We've been pretty ineffective in getting medicines. And so if our vaccines fail and our medicines are failing, there's an issue there about our long-term capability to keep this virus at bay. And one of the things let's talk a little about long haul effects. Right now, when we think about vaccines and we think about the modeling we've talked about, we said, there's a 20%, and what I've said is there's a 20% chance or so that the variants are going to beat us every year, and we're going to have to create new vaccines every year. And there's an 80% chance that we'll be able to control the variants. And if we are able to control the variants, we'll be healthy. Now, if we're unable to control the variants, there's going to be a very high death rate. Well, it turns out that actually, if you're on this path, it isn't really a binary path. That in fact, if you control the variants, and still a lot of people are getting COVID, but they're remaining healthy, which is the case in the case of if you're able to reduce pathology, you can still have an awful lot of disabled people, because it turns out that long haul COVID is not related to how powerful your disease was. In other words, your symptoms were. So if you could have had, been in the hospital for 6 months and never have long haul COVID, and you could have been completely asymptomatic, completely unaware that you even had COVID. 3 weeks later, you're in the hospital because you've got, a major blood clotting problem. It's literally at that level. There's no correlation between symptomology and pathology of long haul COVID. And the problem is, as Jean said, it's incredibly prevalent. We just don't recognize it yet. And so we now have a PAX. It's a post-acute COVID syndrome or sequelae PAC that we could now call long haul COVID. WHO has actually created ICD-10 codes for this. They proposed, it's still not available yet, but with that, we'll be able to start to actually monitor how much we're spending on this and be able to quantify how many diseases we have. We think that we have 29.3 million cases. Total case, including asymptomatic, is likely to be 60 to 70 million. We've got 500 million deaths. And you can see that ultimately, when you go through all the contortions, we think we have about 20 million, probably close to 20 million people with long haul COVID in the United States right now, and it's growing all the time. And here's how how long haul COVID looks like. First of all, More women than men get it, about 30% more. Men are more likely to die, but if you survive COVID like women do, more likely to have long haul COVID, sadly. And this isn't something that just comes and goes. It's something that lasts generally for 3 to 9 months and longer. Right now, we've only had 9 months of exploration. 33% of cases worldwide, these people can't even return to work. So they're talking about that level of disease state and impact. And of course, we have no tests to really determine whether you've got long haul COVID. In fact, it infects 10 different, we think probably it has 100 different systems and 10 organ systems, and about 100 different complaints that people have with symptoms. And you can see that basically it goes through a cycle of disease. In the first month or so, you have a lot of gastrointestinal, head, ears, nose, and throat, and pulmonary, have trouble breathing. Then it moves 3 to 4 months later, you have much more cardiovascular tachycardia, a lot of dermatological rashes, people lose teeth, musculoskeletal problems, you develop rheumatoid arthritis, neuropsychiatric problems, a lot of depression comes with this, obviously, because you're not feeling good for a long period of time. Pulmonary, actually people take x-rays and you get the opaque lung, which a glassy opaque lung, and this means that basically it's full of fiber instead of full of air. People can't breathe effectively, and of course you've got lots of systemic effects, and the continuation of the gastrointestinal goes all the way through this because your autonomic nervous system is affected. And then finally 4 to 5 months and longer, you've got the complete list of everything moving in, especially on the long-term cardiovascular, dermatologic, musculoskeletal, and the psychiatric. And this is all contributing to this mental health pandemic we've got. We've got 31% increases in depression, 26% increases in anxiety, 13% increases in illicit drug use, 50% increases in some areas of deaths due to overdose since March of last year. To have that kind of increase in a year, unheard of. And it's all because we're social animals, not able to get to do that anymore. And we're not sure about how long these symptoms are going to last. In most cases, these are permanent symptoms that are occurring between many organ systems. And the problem we have is, in our healthcare system is we will go to a cardio specialist, we'll go to a renal specialist, a hepatology specialist, but it's very hard to find someone who can really treat all these things simultaneously. So you're going to all these different specialists, all of whom don't understand the etiology, what you've been through if you're asymptomatic. And then, and of course, the primary care physicians can't care for you at all. So you're slipping through the cracks of the system, but unable to get any help. And these are the kind of things that are happening to people. They have, they have a new triggered autoimmune disease like rheumatoid arthritis, chronic fatigue syndrome, diabetes 1 is highly prevalent, 30% more prevalent in these groups. Lots of rashes are occurring in the dermatological area. A circulatory system, you've got arrhythmias, tachycardia, myocarditis. These are among people of any age and any sex, and any pre-existing conditions. All those things are pretty much unaffected by whether you're going to get PAX or not. So it's quite right now, with our data set, seems quite random. Central nervous system, huge amounts of cognitive disorder, the brain fog, the inability to focus, unable to smell and taste for 7-8 months running now is something that happens in over 40% of the victims of this disease, for example. And then the other problem is that it affects the entire autonomic nervous system, and that's the parasympathetic, the sympathetic, and the enterotic nervous system. That actually controls your heartbeat. It controls your breathing, controls all the peristaltic flow of your digestion, controls your excretion. You're talking about huge amounts of really life-altering symptoms. And as a result of this, people are trying to finally get together. And right now, about a third of our states actually have clinics that are assembled that actually can try to help you. It's gotten so bad that people are starting to form their own clusters and communities on Facebook. If you look at COVID Survivor, if you look at COVID Long, those kinds of groups. If you have this condition, I can send you some notes about where to go and get help. People are finally starting to come together. WHO published a huge article a huge booklet on this, I think on February 5th, about how to deal with long haul COVID. So you're starting to get an acceptance that this is a real problem, which is the first step. That's the diagnosis, which is helpful, but it's just not happening fast enough for these people. We're talking about 20 million people, so you're not alone. Go out and find your team, and you can get a sense of, this changes the way we should view COVID. It isn't really all about, am I going to be healthy or am I going to die? There's this, and you can see that we think we're going to, in 20% of the cases, we may not be able to control the outbreaks. So we got a 20%, in the red there. The healthy side was supposed to be 70 or 80%, but instead of that, it really breaks down into, well, I'm healthy, but I have a lot of disabled people because I controlled it in my own way, but I haven't controlled the long haul COVID. And so the outcomes here on the policy decisions are quite different when you think of it, not in a binary sense, but in a spectrum of disease sense. And we have to start thinking about it that way. And that'll be a lot more of the conversation in the future. If we get the acute phases of COVID under control, the next step is to talk about the long haul COVID and what that does. You can see that right now, I just wanted to very quickly say that we're on the purple curve. That purple curve was generated based on the very best possible rollout of vaccines. I'm part of that, thank goodness, program. So we're clapping ourselves on the back. The truth is that a lot of this is because it's seasonal, a little bit more seasonal than we thought, and because we're not detecting as much as we should. It's more likely that we're closer to that blue line, which is the middle of the road line, than we think. We just don't detect it right now, unfortunately. But we are well off the no vaccine scenario, which is great. And unfortunately, when you do all the modeling work, even when you come down quite a bit, you don't have to relax the bounds very much in terms of how durable the vaccine is, in terms of how whether you get your second shots or not, in terms of how fast the variant breaks through, to get really high breakthrough rates around next Christmas again. So it'll start to bubble up October, November. If we're not in as much control as we think, we'll start to, from the variants, we'll start to see that. It will have a good summer, but be careful kind of October onwards, but especially late October, November, December. We could have a bounce back. We'll run, we're planning to have in 2 weeks another discussion. It'll be about economics. And we'll do a lot more modeling for that with DSmart, which I appreciate their support. We're going to run some interesting models there, and we'll run that next round. So it'll be a very different discussion in 2 weeks. It'll be a discussion not about the biology, but about the economics. Here's a little teaser. Here's how much we're spending. Here's the COVID spending package. This is the recovery plan that we've got right now, or the relief plan that we've got right now. And you can see that right now we're spending $100 million out of our 5.8 total trillion investment. That includes the Fed's investment in the COVID response, is going to defeating COVID. And
0.1% to defeating COVID.
0.1%, yeah.
0.1%.
So we are thinking that we've already won this war, and my suggestion is it may take a little bit longer to win the war than we think, and it may go on for longer and cost more. And more importantly, the leverage of trying to go after COVID is significantly higher than the leverage of giving of not defeating COVID, opening up the economy, and then finding that we have to shut it all back down again and reinvesting in the direct-to-consumer one-time hits that we're investing in right now. So that's a little bit of a teaser for next time. I wanted to tell you quickly some of the answers to the quiz review. That is, will dramatic declines in case of death rates be safe to fully open and permanently reopen the economy June 2021? Premature to say that. We don't. If you hear people say that, I would think about what we've talked about tonight and ask them some difficult questions, especially around what they mean by herd immunity and whether they consider the international impact of reinfection or not. Do high efficacy of the vaccine mean that once I'm vaccinated I can relax and return? And the answer is no. From the epidemiologists you saw, basically they're saying, yes, you can do certain things on your own, especially one-on-one with one other person who's also been vaccinated, no problem. But once you introduce a third, fourth, fifth, sixth person, you're not sure what the transmission rates are or what their levels of protection are, and most importantly, what they're susceptible to, and what their other conditions, what their other health conditions are. You'll have to continue to wear a mask. My recommendation It's likely through the fall.
75% around you are vaccinated.
Yeah, at least, depending on what, and I'd monitor that because some of the variants may be, especially in New York, it may take you longer and require even higher levels. Vaccine allow us to eradicate COVID-19 by, and the answer is we're not going to eradicate COVID. We will control it, but our technology, we've let it go too long. So we'll be constantly, I think in our lifetimes, we'll be constantly on the lookout for COVID outbreaks and managing COVID outbreaks, if not in your own community, nearby, and certainly on a global basis. And expect annual boosters on your current vaccines, even to control this thing. J&J vaccine good? The answer is, you've heard it, yes. Don't, but make sure there are some interesting differences between these vaccines because their technologies are different, especially with regard to if you're diabetic and if you're older. Watch those populations and the health conditions that are being tested and the reports. Talk to your doctor about that, because there are some important differences between some of these vaccines and their effectiveness. Right now, we're just saying everyone get them injected, but slowly but surely you'll see some recommendations in that space. Now we have vaccines. Do we still need to invest in massive testing programs? If I haven't convinced you that we don't know what we're doing, I don't know what will. We're shooting in the dark completely here, and we shouldn't be. And we should really have an infrastructure in place that tells us what the level, for example, of death is when you get COVID. We don't know that. That's the IFR, the infective fatality. We should know about super spreading. We have no idea about super spreading because we don't contact rate. We should know the level of prevalence. We have no idea what the level of prevalence. We have no idea what the what the serology is right now of this disease. And not knowing that means that you cannot target your interventions, even if they're super effective. It's like, having an atomic missile and not knowing how to aim it. And that's what we got right now. And there's a huge opportunity to create AI and add big data to this, really improve health on a global basis, and to prevent future infections that we're missing right now, which is disappointing. Here's what your personal risk. The way to think about having a vaccine is you should act as though you're an asymptomatic carrier and that everybody else is also. And if you do that, you won't make too many mistakes in this transition. Slowly, we'll be, especially when we find out more about transmission rates, we'll be able to relax that. That's sort of the default position you should be in. So if you want to get together with small friends and a single other family, if everyone's vaccinated, especially if you're outdoors, if you're indoors, not so much. We're not as protected so much anymore. And choose your events wisely. Don't go to a big bar and try to use your one chip, if you will, of risk at that. Instead, really build the relationships that matter to your emotional and mental health. Try to rebuild those that are really important. It turns out your exposure is 1 over the distance times ventilation times mass performance. Thank you, Arthur. The physicist comes out through our group, and that's true. That is the formula. So what that means is, for goodness sakes, continue distance, continue ventilation, continue with masking to get the best mask you can, and avoid the opportunity for don't forget these infection particles are cumulative over periods of time. So just because you're in with, for 5 minutes with one person, then 5 minutes with another person, and 5 minutes with another, and you're doing that for 6 straight hours, you have as much infectious opportunity, and probably even more, considering variant issues, as someone who's been with one person for 6 hours. So, understand that equation, because this stuff is cumulative, the events are cumulative, and understand, more importantly, that your danger is equal to your exposure times your personal risk profile of the most at-risk person in that group. So if you've got a lot of pre-existing conditions that are going to cause you to have a bad COVID outcome, really insert that into your equation. Everybody is different. Everyone has different acceptance levels of risk. Everyone has different true risk that they're facing, and you have to just respect everybody's final decision about what they want to participate in and what they don't want to participate in, and you have to be flexible about that in your own life as well as everyone you're interacting with, and of course you really want to continue your personal precautions based on that. And don't forget that even asymptomatic infection can cause PAX, and you really don't want to have PAX. So with that, I wanted to tell you March 28th, we'll talk about economics. I wanted to thank all the people who really helped. Wow, you know, it's becoming a great and high performing team. I really appreciate, you know, Christine has been at it from the beginning, Tom also from the beginning, Arthur and Cynthia joining. We've got a number of other groups, Tanya, Colin, Beth, of course, Bobby, and D-Smart, and Jean, thanks for putting it all together. Really appreciate it. And here I am. So go ahead if you have questions.
Okay, thank you, Fred. I have been asked by the team to give a few ground rules because we do want to be respectful of people's time, and we also want to make sure we cover the most important and pertinent information. So let's try to keep our questions to the information we covered tonight. Last time we had a lot of questions on best practices, and we're actually thinking if you have a lot of those, put them in the chat. Arthur and Christine and myself are all grabbing those chat questions. And so we might even have a special Zoom session to discuss best practices in the next week or two.
Oh, I'd be happy to do that. Yeah. Yeah. What do we do with CDC guidelines? What do you do with if one person's vaccinated, one person's not? Like, I'd be happy to do
Yeah,
that.
I want to do a Fred Brown town hall best practices. And so I'm going to work with Arthur and Jean to set that up.
I do that all the time with you know, communities. They're easy to do.
Okay.
Yeah.
It's called a brown hall.
Yeah.
So I'm
Or a
going,
long haul. That's right. Sorry about the long hauls. I can't get through the material test.
Fred, I'm going to start asking a few questions that came in over the chat. And then I'm going to ask people to
He's doing another one about the
feel
economic.
free to ask questions or raise your hand and we'll call you out. But Kurt Becker sent a few questions in. But before that, Fred, the question
That'll be all new.
I ask you at the end of every single talk, how optimistic are you on a scale of 1 to 10 between where we are and where we're going over the next 6 to 12 months?
Jean, that's a loaded question. I hate that question. It got us in trouble. You have to ask it.
I think over the next 6 months, I'm optimistic we're going to come down a curve. As I said, we are. I mean, if you do all the modeling math and all the input from the manufacturers, we're doing about as well in the rollout as we can, but we are missing a lot of the detection. Unfortunately, we're probably about 20% off. Overall, I think our summer is going to be a good summer. I think our fall could be a tough fall.
Okay, great. Thank you, Fred. Okay, so Kurt had a few questions. One is, why are SARS-CoV-2 infections dropping worldwide, even countries that are not yet vaccinating much?
Yeah, that's a great question. The vaccines have not had a chance to kick in, with the exception of probably two countries. Even for the United States, we don't think we're going to see much of a shift until we get at least 50% vaccination rates for the first-time vaccination, and we're still 15% off that. So we're seeing that in the United States. We are not seeing that so much in Europe. So that's a little bit interesting. So in terms of new cases, the answer is we're not sure. But we're happy to take what we can get, frankly. And every country is a little bit different. So in Europe, we're seeing a rebound, for example, which is very concerning because of the B117 variant. And some of the lesser developed countries, you're right, we're seeing continued downward slope. There are a number of reasons for that. In some countries, they're not testing as much. In other countries, they got a better way of blocking the virus than we do. The wealthier countries actually are having the worst case rates versus the poor. We're not sure whether that's a testing function or whether that is a function of these countries have a better innate immunity because they're more exposed to more pathogens and because they are better at masking and NPI than we are. What's interesting is we're particularly, we really kind of, the United States is particularly bad sadly in our response compared to other countries. And so it's hard for us to imagine that other countries really do have, 95, 96, 97% masking, that their mobility rates are down 40, 50%, that their economies are largely younger, so that they've got 50% of their population is less than 15 years old. So in the LDCs, you're seeing a combination of that versus in our countries where we're older, where we haven't shut down our economies really at all, comparatively, and where our mobility has only gone down 15 to 20%, and we really haven't done the masking. I know that we feel that we have, but we really haven't done the masking that a lot of other countries have.
Okay, thank you. Jim Angel just sent in a question. Why are we not doing more testing and sequencing? What are the roadblocks? Whom do we need to influence?
That's a great question. So right now we're trying to go up to 25,000 sequencing tests a day. That's a 20-fold increase or so. The reason that we're so bad at it is twofold. Number one, we don't ship. So what the UK, probably the best practices in the UK, what they did basically in a month, literally, I think basically within a month, they had set up a system where any positive antigen test that came back, a positive PCR test, was able to be shipped immediately to have a genetic sequence done on it. We don't have that kind of capability where we say, here's a positive test, and therefore we want to go ahead and ship it. The only instance where we have done that successfully is New York, because we're so desperate about the 1526 variant, where we can very quickly see on the PCR test, okay, that one's a positive and it's a variant that we're of concern. Let's find out which variant of concern it is because of the lack of the S protein. And then we sequence that. And as I said, we're doing about 3,000 of those, so 1,500 of those a day out of New York City. And that's our best environment. The thing that stops us is they're just, believe it or not, the sequencer capacity is pretty shot. These sequencers are bought, years in advance. If you talk to Illumina and others, they're and they don't have as many as we'd like. If we could use them and immediately fill them up, labs up, we then have two more problems, and that is the number of qualified personnel to actually do the testing. It's becoming simpler and simpler, but these really fast, high throughput ones do require quite a bit of technical skill set. And the third issue, believe it or not, is reagents and pipette tips. We're running out. We're running out of some of the more critical laboratory tool sets that we need in order to actually run this. So pipette tips, reagents, training are immediately solvable. I think certainly within a few months, as is trying to get people to ramp up the sequencers output.
All right, thank you, Fred. Another question from Kurt. Ireland just suspended use of the AstraZeneca vaccine because of clotting incidences in Norway. Did this decision make sense, or was it an overreaction?
So I have looked at some of that data. I think it was an overreaction. I don't think it was statistically significant, and I don't think it could be linked directly back to the injection. We don't know about. I don't have access to the lot numbers and the manufacturing sites and so on that that those particular vaccines went through. It could have been that there could have been some kind of contamination in those particular lots going only to Norway. It just is. There are a couple of other countries that have done that as well, by the way, that they have had some clotting issues, and they have stopped the AstraZeneca vaccine temporarily to see whether that continues. Right now, the AstraZeneca vaccine, the clinical trial was 11,000 participants with the active, as I recall. We're now up to several. We're up to tens of thousands of people having taken that vaccine without this complaint. So I don't think it was something that is unless we see more of this across more lots and across more geographies under more conditions. We don't have the direct correlation back to the vaccine yet.
Okay.
They were being Norway and the Northern Europeans are particularly sensitive to and try to be extremely protective of their populations. So they tend to overreact and then watch rather than to take a chance and keep going. And they do have alternatives, so they took those alternatives.
All right, thank you. Another question, Merck bought rights to an oral therapeutic from a startup called Ridgeback Therapeutics, spun out of Emory. Some partial results in the past week, but there is suspicion it has to be used super early. Could this go the way of a household distribution so it would be on hand at the first sign of loss of taste, smell, or other early symptoms? Do you have any comments on that?
Yeah, was this the test for taste? I did see that there was a test that came out for taste and smell. It was sort of interesting. You put it on your lips, you put it on your nose. I thought that was Ridgeback's, or is he talking about a therapeutic?
I think he's talking about an oral therapeutic.
Oral therapeutic. Okay, so there are a couple things about the therapeutics. They always are better if you can take them early. The biggest problem we have, as David Seftel, who's a part of one of our HBS colleagues, was on 60 Minutes last week, said it's all about getting something inexpensive that is available in the home. And fluvoxamine is one of those, and Ridgeback. I read so many articles about this stuff. I can't remember all the Ridgeback material, but the oral piece is helpful. Different routes of administration is helpful. Certainly if it's available through your local drugstore and available at home, so they don't have to go and be hospital administered or administered offsite, or all those are extremely helpful. And the earlier you can get it, the better. And that's been our biggest problem with demonstrating the effectiveness of these drugs. We test so badly that by the time we realize that someone is eligible to actually take a drug, they're 10 days into their disease state. If we'd gotten them 4 days into their disease state, 5 days into the disease state by better testing, we would have had so much better. I think we would have many more effective drugs available and a lot better ways of intervening. It's just a shame. So that's all. It all comes back. The answer is yeah. To the extent we have more oral and inexpensive drugs that are available through the drugstore, not through the hospital, the better off we're going to be for this.
Okay, great. So I'm going to open it up now. Arthur, if there are any questions that I missed, if you could ask them, that would be great. Or anyone else that would like to ask a question, let us know.
Yeah, I'm going to jump in with a couple that I captured from the chat. One was, can you talk a little bit more about the outlook for childhood vaccine approval?
Yeah, that's a great question. So childhood vaccines, we're already in the process of trying to inject 12 to 18-year-olds. There's a clinical trial underway with AstraZeneca, with Moderna, with Pfizer, and J&J also is just starting that up. So we'll have something, I think, by September for that age group. Which is great because they are more transmissible than the younger ones, unless we're talking about the V117 variant, sadly. And then it takes us time, actually. People don't want to expose their young children to diseases, to vaccines in clinical trial tests. Once you get below kind of the age of 6 to 12, you start the immunology gets a little bit more closely related to an adult, but under 6, the immunology is quite different. Usually we usually go from 18 to 16, 16 to 6, 6 to 2, and then 2 to newborn. As we roll things out, the 2 to newborn is likely not to be available till 2023. It takes that long because these studies are more than just continuity of adult studies. They're actually full new studies because the immune systems are that between children, especially infants and adults, are that different. The dosing's all different. You've got to worry about the size of the patient. It's actually quite complicated to move to a childhood vaccine from an adult.
Okay.
So I'm sorry. The dates will be 16 to 18-year-olds probably in the fall. Then we'll probably move down to 12 to 16-year-olds probably by early 2022, and then probably the 6 to 12s by the end of 2022, and probably infants by mid 2023, something like that.
Okay, Arthur?
Great. Another question that came in is really about safety. Do the mRNA and adenovirus carrier vaccines enter the bloodstream or just enter the cells around the injection site? And if they enter the bloodstream, are all of the body's cells possible targets of the vaccine, like neurons, reproductive cells? Can they pass through the blood-brain barrier?
Yeah, great questions. The answer is no. It goes in the muscle. The muscle doesn't go into your bloodstream. If it does go into the bloodstream, it's cleared. There's been an extensive testing on that. These adenoviruses aren't just for COVID. They are existing existing viruses for rabies, for herpes, as I recall, a few others. So these are well tested safety and scaled operations. So the answer is they do last in your body for some time. Then you do have to clear them over that time. But they've been treated. What they do with it is they pull out the DNA that's infectious. They replace that DNA, with something that's non-reproducible, and that's that's the vector, and the vector does is put into the intermuscle, and then it does take about 180 days or so to pass. Yeah.
Okay, great. Thank you. Another safety question. Is it safe for a long hauler who got COVID in March of 2020 to get the vaccine? He basically has fatigue and,
Yeah. The answer is yes so far. And if you have been infected, you should probably wait about 3 months before you get the vaccine, because you're right. But given that it was 2020, March 2020, that's a long enough time that you won't reduce the efficacy of the vaccine. So yes, go ahead and take the vaccine. There's plenty of PAX patients who have taken a vaccine at this point. You could, if you're concerned, talk to your specialist about any issues that they think you might have, if they're aware of any. But right now, nothing to my knowledge has been reported.
Yeah, in fact, we should mention that nothing here should be construed as medical advice.
Oh, yes, thank you.
There are no doctors here. Go talk to your personal physician about any personal aspects of your health. Another question that came in, you covered this a little bit, but is there actual data on efficacy of the 3 major US vaccines versus B117?
Yeah, we do have some evidence that indicates a couple of things. Number one, neutralizing antibodies, so it's the equivalent of phase 1, and then we have real world evidence in Britain around the AstraZeneca, Pfizer, and J&J also, that indicate that on a population real world basis, we're seeing a continued reduction, whether or not the population has had a B117 experience or a wild type experience. So right now, it's all real world. It's not straight up challenges. But we think we haven't seen an issue of here's B117 population, here's our wild type population, and we haven't seen a separation in the effectiveness at a population level yet. So we think it's the same. We think it's the same level of effectiveness.
I have a question. Is there any data about how effective, once you've taken a vaccine, you may or may not have symptoms, but be exposed to COVID? Is there any data on how many people who've been vaccinated end up with long-term COVID symptoms? Do the vaccines prevent that as well as serious disease and hospitalizations?
That's a great question, and we haven't tested it. So right now we are still seeing people coming in with long-term COVID, and if they've been infected despite having a vaccine, we believe they still could have a PAX situation. Yeah, but beyond that, we haven't tested anything.
Any other questions? Arthur, have you covered yours? The ones that you
I
found?
think most of them got covered, but if I missed somebody's question, please go ahead and ask it now.
Was one question that could have been just maybe partly joking, but they wanted, when you're in your section about Texas, they wanted to know, I hope Fred is talking to the people, the government in Texas, what you're doing about that.
In Texas, I have, so early days, I did work with Texas, and I still work with Harris County, but I don't have as much influence over Texas as I would like. Yeah. So sadly, you know, I think there were two states, Texas and Mississippi, Texas especially, you know, where the data was overwhelming that opening up would not be a good idea. And if you think about the political situation in Texas at the time, they had I probably shouldn't say this, but they had a big natural disaster just prior to that, and I think they wanted some distraction between us guys. Right.
There was one other question that I could bring to the group, although it was a direct one, but it's just what can we do to help leverage our contacts to push for better governments, or, you know, to get the spending support we need for the things we do. Is there anything specific we could be doing as our alumni group that might have some contacts? What should we be doing?
Yeah, that's a great question. Every day I push, and you know, we were able to get a little bit of you know, $160 billion extra for vaccine transport. That was before that not quite so directive. But the answer is, yeah, I would start holding the government and your employers, starting to ask them the question, you know, what do we know about disease level? What do we know about the variant level? And I start to expect that, you know, push them to make that a KPI. And I frequently do that with the states that I work with. Say, okay, you know, how you want to measure, you know, the effectiveness of this program, that program, and so on. And all of a sudden they realize they need to have a lot more data and testing data to know. The other big thing is the FDA is really slowing up the EUAs of home testing. And for me, that is just inexcusable. You know, we should be able to do home tests. There's plenty of good technologies out there to do good, inexpensive, regular home testing. The reason the FDA wanted to hold off on that was they didn't want to lose the data sets. But if they start to at least approve those home tests that have automatic data that's de-identified and moved back to the jurisdictions, it'd be hugely beneficial. So, you know, pushing the FDA, trying and there are now home tests available that you can get through the mail, but we really want to get to is home tests that you can do, you know, every day repeatedly that are accurate. And they've got 172 test backlog that would help us tremendously right now in the home test space that they haven't moved on. So I would push there to push the FDA to start EUAing those. Trying to think of some of the other things on the variant testing. Start to ask for genetic sequence if we have a positive result, or if you know if people who have a positive result, ask what variant they were talking about, so they can start to push the demand on our on that side. And finally, with serology, I would try to see if you can get your employer or try to ask the state to start to regularly test what the antigen levels are, to find out whether or not people are protected with the vaccines, to find out whether or not they've been infected before. And all those data sets are things we can start to ask for, I think, legitimately as part of the overall program of fighting COVID.
All right, thank you, Fred. I want to be respectful of people's time and remind you that if you want to get on the mailing list, you can email me or Christine. The current website is www.fredbrown.com, and we do have a Google group, so you can be put on that for additional upcoming events or information. The slides from tonight's talk will be posted on the Fred Brown website in the next few days. And we will also endeavor to put a recording of tonight's session there. That typically takes a little longer, maybe a week to a week and a half. So again, I want to thank everyone for coming. Please stay safe, and we hope to see all of you in 2 weeks on Sunday the 28th. Take care all. Bye-bye.